We can start. Right, in your LMS, right, in your LMS, I have uploaded today lecture note 5 and also a tutorial, right? So this tutorial based on what we have discussed last time. So very simple questions, but you should go through what we discussed and try to answer these questions, because for your exam also you will get this type of similar questions, right? So please try to answer these questions, and if you have any questions, you can discuss with me tomorrow. This the first question in this tutorial. This is no need to submit, right? So I will give you an assignment. You have to complete it and you need to hand over it to your department on your exam day. But this tutorial is only for your practice, right? You can do this. You can try to answer these questions. The first question. It asks you that the very first thing we discuss regarding under statistics, we know that we have variables, right? Variable means some characteristic that it can take different values, can vary, right? So when we talked about the variables, we discussed several types of variables. That is, when it talked about the variable can be divided into mainly two parts: qualitative variable, qualitative and quantitative, right? A variable that represents some quality we call as a qualitative variable. A variable that represents some quantities we call as quantitative variables. Again, the quantitative variables we can divide into two categories as discrete variables, discrete and continuous, right? So these are the main classification of the variables we can find, right? And please go through these 4 questions and try to identify the data points that we can observe, that we can collect for these 4 variables, whether these are discrete or continuous. And also you can think about whether these variables are qualitative or quantitative, right? For an example, if you consider the monthly income of a family, suppose you have several families and you consider the monthly income value of a family. Then think about this way. This is a variable. Monthly income of a family is a variable because from family to family, it can take different values. So when we look at the data points, whether it is a discrete variable, continuous variable, whether it can take some discrete values or continuous means it can take infinite number of values in between any two defined points, right? In between any two defined points like 100 to 200, it can take any value in between these two values, right? But if we say discrete, it can take only discrete figures only, right? So go through this and try to find the answer. And also we discussed about the scales of measurements. Mainly there are 4 scales of measurements. That is the variables. How the data for the variables are measured, we can divide into 4 types of scales of measurements. That is the lowest level is the nominal scale. The second one is the ordinal scale. Third one is the interval scale. And the last one, ratio scale, right? Nominal means just nominal, and ordinal scale means we have some, the data points like some categories only, right? For an example, gender. This is a nominal scale variable. The data points looks like only males or females, right? And also those two categories, I cannot order, I cannot rank them. I cannot say that male category is greater than the female category. But if we consider ordinal scale variable, that means, for an example, if I collect the data like job satisfaction, education qualifications, right? The data points are again like categories, but those categories I can order. I can give some rank, right? And the most of the other variables we can consider as interval or ratio. Right? If the variable is ratio scale variable, we know the main point that is the ratios are meaningful. We can define the ratio between any two different values. The ratios are meaningful. And also the 0 point, right? Here we discuss. It has actual 0 point, true 0 point. But interval scale variable, it has not that property. We cannot define any ratio, so it has no meaningful 0 like that. So go through the note and try to identify the scales of measurements also. Right? And I have uploaded the data set we discussed, pulse data, right? In your LMS, you can see pulse data set. I uploaded this Excel file, data file, because I said you need to have some knowledge about what's mean by data, right? Because in statistics, you are learning some concepts and you are learning some concepts we need to use when analyzing the data. Right? Those are actually not theories, but these theories you need to know when you want to analyze a data set. Right? So first I said you should know what is a data set. For an example, right? This pulse data set I showed you last time in your slides. You have a part of this data set. This is you can see here. This is Excel file. Excel file, it contains here from column A to column H, up to column A to column H, you have several, I can say these are several data, right? I have a data set. I have a data set here. So each column, it gives a name, column name, pulse 1, pulse 2, rank, smoke. The last column name is activity. You can see under these columns, you can see different types of data. Right? In column smokes, data recorded as yes or no. In column height, data recorded as 66, 72, like some numerical measures. Here, data recorded as some text text values. So we say these columns show some variables. This name shows some variables, because if we say pulse 1, it can take different values. If we say smokes, it can take different values. What are those different values? Yes or no? If we say weight, it can take different values. So weight is a variable. Activity is a variable, right? But here you can see I have 1, 2, 3, 4, 8 columns, data for 8 columns and 4 rows, right? If we go through the rows, the first row goes to the titles, and totally I have 92 number of rows. That means 92 number of records I have. 92 number of records I have in this data set. Right? So when we talked about a data set, it looks like this. It has columns. As the columns, we have the variables, and as the rows, you have some records. Then what this data says us, how this data collected, what is mean by pulse 1? What is mean by pulse 2? What is mean by height, activity? We need to know about the meaning of these things before analyzing the data. Right? Otherwise, you cannot get any idea of what this pulse 1 says. I don't know. What is this pulse 1? And whether this 64 this comes from what? I don't know. Right? So we need the story behind the collecting of this data set. Why this data set has collected? What is this research? Right? And what is the sample size? Why they have collected this data? What are the objectives of the researcher? So we need to know about these things. So we always say that we need a description of the data set. Right? So there is another file I have uploaded to the LMS. It contains under Pulse dataset, Pulse data description. This Pulse data description PDF file shows you, this file gives you, right, the story behind collecting this data set. Right? This table shows you, first column shows the 8 variables, pulse 1, pulse 2 up to activity. And for each variable, I have 92 number of data points in the Excel file. For under each variable, I have 92 number of data points. Right? So the next one is, this is the very important, the description of the variable, what this pulse one says. Here you have the story. The researcher has collected this data from some students, right? From some certain number of students, 92 number, actually it's that we know the value, 92 number of students who are in the basic statistics course from a certain university. They conducted some experiment and collected this data. They want to identify how the pulse rate vary with other factors. How the pulse rate vary with other factors, other variables, right? For that, they collected pulse rates for those set of group of students and some other variables like RAN, smoke, sex, height, weight, activity, some other variables. And also, right here, the description, the variable description is very important because it says, if we say height, it's the height of the student measured in inches or measured in kilograms. The units also very important. The data measured units, that the data are measured, also very important, right? And in some situations, right, here you can see in the data set, right? In the data set, here we can, for the variable activity, smoke, sex, RAN, the data recorded, data entered to the Excel, right? Excel using some text values, yes or no, male, female, lot, slight, moderate, like that. Rather than entering the data like this way, using text values, you know that when I want to enter this point, I have to type moderate. Here also moderate a lot. Like this, I have to waste some time when entering the data, right? That big names. So what we can do, instead of typing these moderate, lot, slight like that, in practically what we do, we assign some code. We use some code, right? Here, this is the code. Instead of slide, rather than typing slide when entering the data, I use 1. Instead of moderate, to denote moderate, I use 2. To denote lot, I use 3. And here also like this. Rather than typing these text values, very easily we can input our collected data to the Excel file using these numerical figures. 1, 2 values, you can use any number, right? Instead of 1, 2, you can use 10 or 20, right? You can, instead of 1, 2, you can use 10. And so female, you can use 20 to denote female. If we find somewhere 20, that means a female, right? This is we called as data coding. Data coding. These things are important when you are entering the data. Right? And also, this data coding we use to enter data. We can enter the data very easily, but after entering the data, you need to analyze this data. Right? You need to analyze this data. So you should know what are the meanings of these numerical figures. Right? Here in this data description, the slide, the part of the data set I have given last time in your slide, it contains like this way, all the data points are entered as using some numeric figures. right? So then what I want to know, what are these 1 and 2 values, right? If you know the codings, if you have this data description, you know these things. So you can analyze the data. And the next point is, before analyzing the data, you want to know the variable types and the scales of measurements, right? Because we discussed about how we analyze the data. When you're analyzing the data, the first thing is we analyze the data using descriptive data analysis. Descriptive analysis. Or exploratory data analysis, CDA analysis, right? For this means just we summarize the data. We describe the data we have. Then how we describe the data? How I describe the data in Pulse 1, how I describe the data under smokes, how I describe the data under activity, right? We want some methods. We discuss those methods. We can use some graphical output, some graphs. We can use some summary measures, summary statistics like mean, median. We can use those things, right? We can use some graphical outputs like bar chart, pie chart, histogram to describe these collected data, right? But in your stage, you have to do all these things using manual calculations. But we know today we have the software. Excel also you can use to do this analysis. And we have Minitab, SPSS, R statistical softwares we have. But you know the theory. For which variables we can draw pie chart. For which variables the bar graph is good, right? For which variables we need to calculate the mean, we can calculate the mean. For which variable is it calculate the mean? So you should do meaningful analysis, right? Because after analyzing the data, we have to give conclusions. Here I analyze some sample of data, and finally I want to talk about what this data says. We have to analyze the data. We get some out, we analyze, and we have to interpret what this output says, and we need to give some conclusions. So for all these things, the theory is very important. The theory you have learned is very important to all these things very correctly, correct manner, right? So we discussed last time these things, that is what we can do, the very basic things under descriptive data analysis, right? We discussed about graphical outputs and some summary measures, and today we have to start from here. One like percentile, quartiles, and deciles, right? So in your tutorial, so please try to complete this one, because in tutorial you have in this tutorial, you have the third question. It asks, you have given some data, present the following data using a suitable diagram and comment on it. Comment means what can you say by looking at this graph? You have to find out what is the suitable graph. You can use the suitable diagram to present this. Now go through this data and see what are the data you have here. One column you have given the variety type. Some suppose these are regarding some tomato plants. Tomato variety. There are 4 varieties of tomato, right? Under each type, you have given the yield in kilogram per hectare. So how I present this? Now here it is presented as a table, right? So if you want to use some graphical output, what is the output what is the graph you get? Can you draw histogram, or can you draw bar chart or pie chart, right? Think about it and go through the notes we discussed and try to draw the suitable diagram to present this one, right? I said to you, when you are getting some outputs, that means when you are analyzing the data, you have to, after analyzing the data, you have to present these things for some audience. Sometimes you have to click their slides and show what are your findings, right? Then you have to think about who are your audience, whether they can understand these numerical figures. So you have to identify what is the most effective way to present your data, whether we use these type of tables or graphical outputs, right? So we learn those things because those things are really important when you are analyzing and presenting your results to others. And also the fourth question, it contains, you have given some data, right? Data like a frequency distribution, right? Here your data are the weekly wages, right? Weekly wages, these are the data, but the data, weekly wages, here you have given as some class intervals. The data given as class intervals, right? 10 to 14, 15 to 19, 20 to 24, like that. You have the wages, weekly wages as class intervals. And under each class intervals, you know, the number of workers. Number of workers belongs to number of workers, weekly wages 10 to 14. 19 number of workers, they have the weekly wages vary from 15 to 19. Like they say, you have some data that this is not the summary, raw data, this is actually a summary, right? The raw data summarized as a table. So using this one, it asks to comment on the shape of the distribution by drawing a histogram. Using this frequency distribution, we discussed how we draw histogram. You need to get the class boundaries, and you have the class frequencies, and you can draw the histogram and see the histogram, and according to the shape of the histogram, identify the suitable measure to talk about the center. Now we are still talking about the summary measures, right? Last time we started to talk about measures of central tendency. That means uh, if you have data, for an example, suppose your weekly wages, when I draw histogram, your weekly wages are like in this shape, right? Suppose this is the histogram of the weekly wages. So this x-axis shows my variable, that is weekly wages. So using the class boundaries, I can get this type of a graph. Suppose this value is 10 and the highest value 69 or 70, right? So now what can you say? Now what can you say about the shape of this histogram? And what is the suitable measure to talk about the center? What is the suitable central tendency measure? That is, this is the distribution of the histogram. This is the distribution of the weekly wages. We can identify what is the distribution by looking at this histogram, and also we can say what is the suitable central tendency measure to talk about the center. Center means the middle point, right? If you want to talk about the middle point of the weekly wages value, what is the suitable measure? What can you say? What is the shape of the distribution? Shape of the distribution of the weekly wages here. According to this diagram, what is the shape? What is the shape of the distribution? It's look like a bell-shaped curve, right? Bell-shaped one. Here we can say when I go through the overall shape, I can see this type of a shape. Okay? I can by covering all the data points, I can draw this type of a curve. So I can say this is like a symmetric around the center. This is the center, symmetric around this line, right? So it is not skewed to any side, right or left, but it is symmetric. It's like a bell-shaped curve. So you can give a comment like this, the weekly wages, right here. What is symmetrically distributed? The data, right? These are, here you have the data. In this first row, you have the data. This data are symmetrically distributed. Like when I explain this one using this pulse one, right? Pulse one data column. Like here you have several numerical figures, 92 number of numerical figures. If you want to know, suppose you want to know by looking at these values, you cannot say anything. You cannot just you can find only the maximum and minimum values, but you cannot say anything about the distribution. You have to summarize it. Right? The suitable graphical output for this type of quantitative continuous variable is a histogram. So by looking at the histogram, we can say whether this is a symmetrically distributed one or not, right? So this right. So this one for the fourth question, you need to draw this diagram manually and try to comment on it. Right? And the fifth question is a very simple one. You have simple, very small data set. Calculate these summary measures. These are all these summary measures, mean, median, and mode. All these measures talked about the center of the distribution. Mean is the average value, right? Median and mode also average values, right? So how we calculate those values? Right. Do you have any questions? Any questions? Right. I will show you. Right. This is not, no need to know about the software in this stage, but when you are doing your research studies, you have to analyze the data using this type of software, right? This is a Minitab software, very user-friendly software, and you can, here you have the menus and you can enter the data. This is like here in the worksheet, this is like an Excel spreadsheet. You can enter the data here, and using these menus, graphical graph menu, you can get graph, pie chart, bar chart, and histogram, right? And under stat menu, you can calculate some summary statistic, descriptive measures, mean, median, all these values we can calculate, right? So, but in this page, right, for your exams, you should know how to calculate those manually. But I will show you, right, what I am talking here. Suppose I have this data, right? I get a copy of this data set from Excel. I get this to Minitab, right? I paste here. Right now, let's see when how I draw the histogram, right? To draw the histogram, we need the class boundaries, but using the statistical software, very easily, I need to give the variable name only, right? Go to graph menu and go to the histogram, select this option, and I want to draw a histogram for the pulse one, right? Was the I have only one variable, so this is the simple one. Select this one, click OK. Now here you need to give the graph variable. I want to draw a graph histogram for the pulse 1. Give the variable and click OK. See, it gives this graph, right? You know how to manually draw this one, but at once when you give the variable, you can get this output. This is the histogram. So this, by looking at this histogram, we can see whether the here x-axis shows the pulse one data, this individual data. Using this data, 92 number of data point, it constructs this class intervals, and considering the class boundaries, it draws this diagram, right? Here y-axis shows the frequency. So we can get some idea about which type of a distribution it has, whether it's a symmetric or skewed one. We can get that idea. So these are the things, right, we are going to do when analyzing the data. But the important thing is, right, we discussed about the variable types and scales of measurements. I said you want to get a clear, you should have a clear idea about the variable types you have, data types, scales of measurements you have, because for all types, all the variables, you cannot draw a histogram. For all the variables, you cannot draw a bar chart, right? You have to select the suitable variable. You have to select the suitable graph for the suitable variable and use the software to get this output. Otherwise, sometimes the software, if we say give a histogram for the variable activity, sometimes the software will give an output, but it's maybe it's a wrong output, right? So you should know to do the correct thing. That's right. It asks in the chat box, explain a little bit in Sinhala also, right? I will explain these things in Sinhala. ඔයගලන්ට අපි දැන් මට ඕනේ මෙතනදී පොඩි සමරි එකක් දෙන්න විතරයි අපි මොනවාද මේ ඩිස්කස් කරේ කියන එක. අපි කතා කරේ මුලින්ම data set අපි statistics වලදී කතා කරන්නේ අපි data ගැන. right? කොහොමද data analyze කරන්නේ කියන එක. එතකොට data set එකක් කියන්නේ මෙන්න මේ වගේ දෙයක්. ඒකේ තියෙනවා අපි එකතු කරපු එක එක variables සඳහා එකතු කරපු data තියෙනවා. ඒ data numerical values විදිහටත් තියෙනවා, text values විදිහටත් තියෙනවා. හරි. එතකොට මේ data analyze කරන්න data enter කරද්දී අපිට එකතු කරපු data Excel file එකක enter කරගන්නත් පුළුවන්. එහෙම නැත්නම් අපිට පුළුවන් ඒවා statistical software එකකට කෙලින්ම directly enter කරගන්නවා. ඊට පස්සේ data enter කරායින් පස්සේ මේ data analyze කරනවා. analyze කරනවා කියන්නේ මේවට graphs ගන්න ඕන, tables ගන්න ඕන, mean, median වගේ values calculate කරන්න ඕන. ඒ කරන theory තමයි අපි කලින් කතා කරේ. එතකොට ඒ graphs කොහොමද එන්නේ කියන එක අපි දැන් graphical graph menu එකට ගිහිල්ලා මම graph එකක් තෝරලා variable එක select කරොත් එයා graph එක ඇඳලා දෙනවා. හැබැයි ඔයගොල්ලෝ දැනගන්න ඕන මේ එක එක variable සඳහා අඳින්න පුළුවන් graphs මොනවද? දැන් අපි pulse one වලට histogram එක අඳින්න පුළුවන් වුණාට මට මේ rank කියන variable එක present කරන්න histogram එක අඳින්න බෑ. ඒක අපි කියන it is not meaningful. මොකද හේතුව මේ rank කියන එකේ data දිහා බැලුවොත් දත්ත තියෙන්නේ yes or no විදිහට විතරයි. ඒ කියන්නේ categories දෙකකට විතරයි data තියෙන්නේ. ඒකට මේ categories දෙක කොහොමද මම present කරන්නේ? මම මේ categories විදිහට තියෙන variables එකක් present කරන්නේ කොහොමද කියන එක අපි වෙන විදිහකට කරන්න ඕන. ඒකට මේ histogram එකක් පාවිච්චි කරන්න බෑ. ඔයගලන්ට එක්ක පුළුවන් table එකක් අඳින්න. මේ yes කියන category එකෙන් කොච්චර percentage එකක් තියනවද? no category එකෙන් කොච්චර percentage එකක් තියනවද? එහෙම නැත්නම් pie chart එකක් අඳින්න පුළුවන්. හරි. මේ විදිහ graph එකක් අපි manually යන්න pie chart එකක් rank කියන variable එකට මම pie chart එක pie chart, right? Here, the orange color shows the no category, and this is the pie chart for the variable rank. Green color shows the yes category. So only two categories in the variable. Data තියෙන කොටස් දෙකකට විතරයි. ඒ දෙක present කරන්න පුළුවන් හොඳ විදිහක් තමයි pie chart එක graph එකකින්. හැබැයි මේ rank කියන variable එකට histogram එකක් අඳින්න බෑ. ඒක meaningful නෑ, තේරුමක් නෑ. එහෙම මේ වගේ එකක් තේරුමක් නෑ. මේ වගේ එකක් අඳින්න පුළුවන් continuous scale එකේ තියෙන data වලට විතරයි. හරි. ඔය වගේ දෙයක් ඔය වගේ ටිකක් තමයි අපි last time කතා කරේ. එතකොට මේ distributions and pulse one වල shape එක symmetric. මේක සමමිතිකයි. Symmetric around some center. යම් කිසි center එකක් වටා මේ center එකක් වටා මෙයා සමමිතිකයි. හරි ඒ මැද වැලියු එකක්. ඒ center එක මොකක්ද කියන එක අපි මේ measures of central tendency කියලා කතා කරා. Measures of central tendency, we discuss about the mean, median, and mode. These are the main important three measures. ඒ කියන්නේ graphically බලලා අපි කියනවා මේක සමමිතික වියක්තියක්. මෙන්න මේ mean එක වටා මේ සමමිතිකව තියෙන කියලා. right? පොඩ්ඩක් try කරන්න. එතකොට මේ අනිත් දේ තමයි මම කිව්වේ summary එකක් විදිහට අපි discuss කරපු මේ variable types. right? අපි discuss කරා variable types ගැන. ඒ variable types ඇයි qualitative, the quantitative, the discrete, the continuous, the එතකොට ordinal scale, ratio scale, එහෙම ඒ scales of measurements ඒවා ගැන කතා කරේ මොකද මේ මේ data analyze කරද්දී table එකක් අදිනවාද, graph එකක් ගන්නවාද, histogram එකක් අදින්නේ, pie chart එකක් අදින්නේ, මේ හැම දෙයක්ම තීරණය කරන්න පුළුවන් variable එකේ type එක අනුව. right? ඒක නිසා variable types මොනවාද කියලා දැනගන්න එකත් ගොඩක් වැදගත් වෙනවා. මේ tutorial එක complete කරන්න බලන්න. right? තව questions තියනවාද? any questions? Right. Then we have to talk about another measure, right? These measures called as the location measures, measures of location. Earlier we talked about the measures like mean, median, and mode, right? Mean is the average value of the data set. That is, when you have some data points, right? Suppose you have this data points. The mean value is the simple arithmetic average. That is, I get the summation of the sum of these values. That is 30 plus 32 plus 35 plus 38. So like 40. Like this, I get the summation of all these values and divide it from the number of data points. Here, how many number of data points? තියෙන දත්ත ගාන. Number of data points 14. Then this gives the mean. Right? So when you have 14 number of data points to calculate the arithmetic mean, how we calculate it? Mean is get the summation of sum of these data points and divide from the number of data points. It gives the average value, talks about the center. මේ ඔක්කොම represent කරන්න පුළුවන් තනි point එකක් mean එක. Then mean is the average, right? Simple arithmetic average. But if we say median is the when we arrange the data set. මේකට අපි කියනවා මධ්‍යන්නය කියලා. Median එකට කියන්නේ මධ්‍යස්ථය, right? Median is the when we arrange the data in ascending or descending order, the middle value gives the median. We arrange the data according to ascending or descending order and middle value gives the median. What the value comes to the middle, we call it as the median, right? So when calculating the median, what you want to do, the thing is you have to arrange the data set into ascending or descending order. For an example, here to calculate the median of this data set, I arrange the data as this way. Like the lowest value is ascending order, lowest value is 30. The next higher value 32. The next one 35. The next higher value like 40, right? 42, 48. Like this way, the highest value 3,800. Then what is the value comes to the middle point? හරි මැදට එනාගේ අපි කියනවා median එක කියලා. Right? So we say if this is the median value, median, below the median you have 50% of the data from the whole data set, whole data, and above the median again you have another 50%. හරියටම දත්ත ටික 150 ගානේ දෙපැත්තට බෙදෙන අගයට අපි කියනවා මධ්‍යස්ථය, median එක කියලා. It's the median. Right? And mode, right? Mode is the highest frequent value. Right? Here, there is all these values represent only one time. So we cannot talk about any mode. All these values are as one time. Suppose there are 330s, mode, then 30, the frequency of the number 30 is 3. Value 30 is 3. So it's the highest frequent value. So the mode is 30. Right? All these values we called as, they talked about some center of your data, center of your data set. Mean, median, mode. Right? So now using this mean, median, mode and summary central tendency measures also, we are going to describe our data, like using the graphical outputs and tables, we describe the data. Other than that, right, for this pulse 1 data, I can calculate what is the mean of pulse 1, what is the median of pulse 1 as a single value to represent, to talk about all these 92 number of pulse 1 data points. I can calculate one summary measure, one single measure, right? It's mean you can, according to the shape of the distribution, you can decide what is the suitable one. Right? So by looking at this data, right, what you can say for this data, right, mean, the suitable, to talk about the center, what is the suitable measure, whether it is mean or median, what you can say? I can calculate mean, median and mode all, right? But mostly we use mean or median. Here, by looking at this data, what you can say? The suitable, to talk about the center of the data, මැදාගේ ගැන කතා කරන්න mean එකද median එකද හොඳ? What is the most suitable one? What is the most suitable one to talk about the center? Talked about median. Median is the most suitable one, right? Why we cannot say the most suitable one is the median, right? May point එක හොඳට ගන්න. Get this point clearly because this is very important, right? To talk about the center, we say we can calculate mean, median, or mode, right? But I said to you, according to your data, you have to decide what is the suitable one, whether it is mean, median, or mode to talk about the center. To this data, I can say that mean is not good. Mean is not good, right? Because here you can see when calculating the mean, we get the summation of all the values in all these 14 number of data points, I get the summation. And I divide it from number of data points, right? Here, in the data, you have some unusual observation. If this value is not 3,800, if this value is 38, no issue, right? Mean is the good measure, good summary measure to talk about the center. But what will happen here when getting the mean, when calculating the mean, this value also in this summation. Because of this value, you will get a wrong value. Actually, the value you will get as the answer for the mean is not the actual mean of these values, because this is a wrong observation. When entering the data, sometimes by mistake, 38 entered as 3,800. Right? So this is an unusual, because we say, oh, if you have this type of unusual observations, what you can do, one thing is you have to correct the data. First, you have to correct this value, check whether this is a mistake. You can correct it and calculate the mean. Otherwise, median is suitable. Right? But why we say median suitable? When calculating the median, just we order our data in ascending or descending order, and which value comes to the middle, I get it is my median. So when calculating the median value is not affected by the values in your tails. මේ tails වලට යන values වලින් බලපෑමක් නැහැ. අනිත් values වලින් බලපෑමක් නැහැ median value එකට. එයා calculate කරද්දී data ටික වැඩි වෙන පිළිවෙලට හරි අඩු වෙන පිළිවෙලට හරි හදනවා median එක calculate කරද්දී මම මැදට එන value එක ගන්නවා. හැබැයි mean එක එහෙම නෙමෙයි. Right? And mode කියන්නේ is a very simple measure. Highest frequent value is the data set. වැඩිම වාර ගාණක් තියෙන data point එක data set එකේ. ඒකට අපි වැඩිපුර පාවිච්චි කරන්නේ mean or median. Right? And these are also another summary measures we can talk about. We call these as like location, measures of locations. අපිට යම් ස්ථාන පිළිබඳව data වල scale එකේ යම් locations පිළිබඳව කතා කර ගන්න පුළුවන් measures ටිකක් තමයි percentile, quartile and deciles. Right? Before going to this one, before going to talk about this, I want to explain another point here. Right? So according to the discussion we had here, I can say you, right? I can say a summary like this. That is, suppose, right, when your data are like in this way, right? Here I am drawing the overall shape I can see after drawing the histogram. Right? Suppose that I have the pulse 1 data and pulse 2 data and pulse 3 data, and I draw 3 histograms, and this line shows the overall shape. Histogram එකේ right? Histogram එකේ මෙහෙම bars දිහා යන overall shape එක, මේ bars ටික යන overall shape එක දිහා බලලා I can draw these curves, right? So we say this is a symmetric one. Make a samamitikkai. This is symmetric around some center. This is not symmetric. This is the center, but this is not symmetric. This is also not symmetric. මෙයා symmetric, හැබැයි මේවා symmetric නැහැ. මේවා එක පැත්තකට මෙහෙට skewed වෙලා. මෙහි ගොඩාක් data තියෙනවා. But here we have very few data points, and but this curve skewed to this side. This curve's data skewed to this side. Here we have a lot of data points, but due to few number of suppose this is 0 to 100 scale, right? Here 0, here 100. This 0, this is 100. Suppose these are the marks of the student. Here I have few number of students have marks like 95, 98, right, 99. Most of the student marks are from 0 to 50. Most of the students' marks are in this range, but I have few data points also. Because of that, I cannot get a symmetric curve. The curve skewed to this side. Right? Here I have most of the students have obtained marks from 60 to 100, but we have very few number of students who obtain marks like 3, 11, right? 21, very low marks. Due to these data points, you cannot get a symmetric shape. You will get a skewed type shape, right? So when we draw the histogram for the quantitative data, by looking at the overall shape of the histogram, you can get some idea about whether your data are symmetric or skewed. Right? Then you can decide which measure is suitable to talk about the center. Right? Still, I'm talking about the center. Here, we say the data is symmetric. We say mean is suitable. To talk about the middle one, mean is suitable. Right? So that are not symmetric. We say the median is suitable. Median value is somewhere here. Median value is somewhere here. Median is suitable. Mean is not good. Not good, because when calculating the mean, I use all the data points. I have to use these very high values and very low values here. And so mean will not give a good measure here according to the data. Right? Any questions? හරිද ඔය අපි කතා කරපු ටිකෙන් ඇත්තටම ඔය mean median ඕවා ගැන කතා කරපුවා graphical outputs ඕවෙන් finally ඔය ටික තමයි එන්නේ අපි දත්ත ටිකක කොහොමද ඒක පැකට් වෙලා තියෙන්නේ කියලා බලලා සුදුසු central tendency measures කියන. ඒකට mean median mode is we used to talk about the center. We say it's also some descriptive statistic. Using it, you can describe the pulse one data. You can describe your variable data in your variable, right? So the next measures are the percentile, quartile, and deciles. We can talk about some location. That is quartiles means here when I have the ordered data, quartile divides your data set into 4 equal parts. That is, we can define 3 quartiles, Q1, Q2, and Q3. Data set එක හරියටම කොටස් 4කට බෙදන අගයක්. Right? So below Q1, we have 55% of data. In between Q1 and Q2, another 55. Q2 and Q3, another 25. Sorry. More than Q3, we have another 25. So altogether, I have the total number of data points, and using the quartiles divides your data into 4 equal parts. Right? Percentiles means, so those quartiles we called as some measure of locations. Metan location එක ගැන measure එකක් තමයි දෙන්නේ. You can say below the quartile we have 25% of data. If you can calculate this Q1 and Q2 and Q3. Right? So we can say above Q3 value we have 25% of data in your variable. Like that we can interpret. Right? Percentile means when we divide the data set into 100 number of points, 100 number of parts. Right? This is 1, 2, 3, like this is 99. 100 equal parts වලට බෙදුවොත් ordered data set එක. These values shows the first percentile, the second percentile, third percentile. Right? This is the 100 percentile. Like this way, we can talk about the percentiles, and the deciles means we divide the ordered data into 10 equal parts. Right? So there are formulas to calculate these quartiles, percentiles, and deciles, but the most important is the percentile and the quartiles are most important. And there is we can say right here for this example, it say you have given some paddy yields, right? You have these data, the paddy yields for 14 plots. After arranging this data into ascending order, uh, you asked to compute the 10 percentile. 10 percentile in notation, how I write it, P10. P10 is equals to Q, right? The 10 percentile is equals to the 10 percentile and the 25th percentile you need to calculate, P10 and P25, right? So this 10 percentile is what? How we calculate the 10 percentile? X percentile we calculate using this formula, x times n plus 1 or 100. N is the total number of data points 14. X is the 10 value percentile and 100. When we look at this, right here, what this says, what is this? This is the value 1. Right? When you simplify this one, this is the 1 over 1.5 item in the data set. 1.5, right? 1.5 item in the data set. Item in the ordered data. Then how we find this percentile value? Here I have the ordered data in ascending order. The first value and the value in between second and first. We have to consider these two values, the first value, the first item, and this half we get from second and first. In between, considering these two numbers, I calculate the half of half value, that is the half point value from considering these 2 points, right? So the first item is 30 and half of 32 and 30. In between these two values, right? This like in a range, 30 and 32, right? So 32 and 30, 32 minus 30, from this width I get the half, right? So the 10 percentile value then is 30 plus 1, that is 31, right? So then how we calculate the 25th percentile, 25th percentile value. 25th percentile value is the, instead of x I have to use 25. So it is, how we simplify this is 15 over 4, right? 15 over 4th item, that is the 3, 4 over 3, this item in the data set. So what is this? The third item plus 3 over 4th point value, like 3 over 4th point value, right? That is the 4th item, 1, 2, 3, 4, third item and the 4th item, this one, and we need to get 3 over 4 considering these two values, right? So that is the point is like somewhere here. So the location, we need to find that actual value. That value is 37.25. How we get the answer? The third item in the data is third item 35. 35, right? 35 plus fourth item 38 minus 35 measuring 3 over 4 pramana. Right? 3 over 4 times 38 minus 35. So the 25th percentile value is this. We can say that this is equals to Q1. This is equals to Q1 first quartile. Because the 125ක් එන තැන value එක. පළවෙනි 125 තැන. Right? So the quartiles mean this is verse 25th of the out of the total data point, when we divide it into 4 equal parts, right? 25% of the data, 25% of the data lie below Q1, right? So when the formulas to calculate Q1, Q2, Q3 are these, from this formula also we get the same, right? 25th percentile is gives the value is same you obtain from n plus 1 over 4th position. Right. So when we want to calculate the first quartile, right? You can calculate it using P25, or you can calculate it using the formula, that is Q1 is the value at n plus 1 over 4th position value. Right? That is all the data points are 14 plus 1 over 4. Right? 15 over 4th position value. The same answer you will find. Right. So try to calculate the Q3 third quartile value using this formula, and go through what we discussed and try to calculate the third quartile value Q3. Any questions? Right, when calculating the quartiles, you need to order your data set in, need to arrange the data in ascending order. What is the third quartile value? Q3. When calculating the Q3, right? Q3 is the value at the 3n plus 1 over 4th position value, 4th position. Right, that is 3 over 4, n plus 1 over 4 means 50, right? That is 3 over 4 by 15. You can, how we write this, right? That is the, we can write it as, right? This one we can write it as 4 by 11 times, right? Right, like 11 over 4th item value, right? 11 over 1/4 item value, that is the 11th value. Here 11th value 1, 2, 3, 4, like this way you can find what is the value comes for the place 11, right? 58, not 55, right? The value and the difference between the 12th and the 11th item, and get the 1 over 4. Right, so this gives the third quartile. So we can say how we interpret this one, how we interpret this, right? This is Q1, Q2, and Q3. So third quartile value is 55.75 means we can say what are our data here are the paddy yields, right? Paddy yields, that means below, right? Here we have below this one, we have 75% data, 75% of the data below this point. And above this point, we have 25% number of data, right? So you can say that 25% of the paddy yields are above 55.75 kilogram, right? Here these are the paddy yields. 25% of the paddy yields are above this value, right? 75% of paddy yields are below 55.75. This way we can interpret. Right, any questions? Right, now let's talk about the dispersion. Right, we talked about the center only, some middle point. Now what is mean by the dispersion? Right, please read these points and go through this diagram and try to understand what is mean by dispersion. Here what you can see, this one, you have given the data. Suppose that we have the distribution of yields kilogram per plot of two paddy varieties. For two paddy varieties, variety 1 and variety 2, right? You have, what are the data you have? The yields. For two paddy varieties, you have the yields for 5 plots. For under each variety, you have the yields under 5 plots, right? That is variety 1, plot 1 value 45 kilogram. Variety 1, plot 2 value 42. Variety 1, plot 3 value 42. Variety 1, plot 4 value 41. Variety 1, plot 5 value 40. Like this way for the variety, right? So these are the data you have. Now what we are going to talk about the dispersion. Dispersion means the spread, පැතිරීම. Data වල පැතිරීම කොහොමද? Earlier we discussed about the mean, median, mode and some location measures. We discussed about some center and some locations on. Right now we are going to discuss about what is the spread of the data, what is the dispersion of the data, what is the variability of the data. We want to know about. It is also important, right? Now here you can see under variety 1, if we apply the variety 1 for 5 plots, sometimes there may be a chance of getting the same value for the yields, but you will get different values. We apply the same variety. Suppose you apply the same variety 1 for equal size plots with equal conditions, you expect the same value for the yield, but you get different values, 45, 42. We call this is there is some variability of the data, right? When we collect the data for the variables, you can see different values. Why is that? Because of the variability of the data. We will not get the same value if we measure the pulse one rate from different persons, you will get different values. From the same person also, in different times, you will get different values. Right? Here we apply the same variety for 5 plots under same conditions, but we get different values because of the dispersion, because of the variability of the data, right? So now under dispersion means we are talking about the variability of the data or scatterness of the observations within the distribution. Earlier we talked about the some average value. From that value we cannot get a clear picture. We can from the mean, median or mode or location measures we can talk about some value, some center or some location only, but I cannot get a complete picture of the data distribution. But here you can see, right, in this graph, this graphs, we say we can get this graph from Minitab software. We say this graph as the dot plot, right? From this graph using a dot, this axis shows variety 1 yield. This axis shows variety 2 yields, and just drawing a dot, I plot the 5 yields under variety 1. Here I plot the 5 yields value under variety 2. What you can see? You can see here data spread from under variety 1. The data vary from 40 kilogram to 45. There are 42 yields. Two plots give the same yield, 42. Right? Under variety 2, data vary from here to here. Dispersion is high. Right? Variety 2 spread is high than variety 1. Yield under variety 2 is high than yield under variety 1. But when we talked about when we go through the mean yield, right, when we calculate the mean of these two varieties, you can get two single values, right? Here, under variety 1, I can calculate the mean. I can calculate arithmetic mean 45 plus 42 up 42 up to 40. I can add these 5 values and divide it from 5. So you will get the value for 40 like 42. And variety 2, you will get the value mean as the 41. By looking at these two values, I can say that variety 1 gives high mean yield than variety 2. Variety 1 gives high mean yield than variety 2. But variety 2, the dispersion is high. Variability is high. Okay, any questions? So now we are going to talk about what are the measures we can use to talk about this spread of the data, dispersion of the data. So these are the measures we can use to talk about the dispersion, range, quartile deviation, right? Mean deviation, and these are very important, standard deviation or variance, right? Standard deviation and variance are commonly used measures of dispersion. And also we can talk about, we can use other measures like quartile, mean deviation, and ranges. Right? Any questions? හරි ඒකෙදි අපි කතා කරන්නේ data වල කොහොමද පැතිරීම කියන එක ගැන. data පැතිරීම කොහොමද? කලින් ඒකෙදි mean, median, mode වගේ ඒවා එක single point එකයි ලැබෙන්නේ. යම් එක්ක මැදාගයක් නැත්නම් quartiles වගේ ඒවා යම් කිසි location එකක් ගැන කියනවා එච්චරයි. 125ක් data මේ අගයට වඩා අඩුවෙන් කියනවා. මේ අගයට වඩා වැඩියෙන් කියනවා. එච්චරයි. නමුත් data වල පැතිරීම ගැන කතා කරන්න dispersion measure එකක් වුණා. Right? So what is the range? Range means the maximum value minus minimum. In your data set, what is the difference between these two values we called as the range. So you have this data, please calculate the range of the data using this formula. Calculate the range. What is the range here?
5.
Yes. Range is 35, right? Range. This range is the maximum value 65. The data ordered from the lowest value to the highest value. This is the minimum value. Minimum value. This is the maximum value. Right? So range is 65 minus 30. So the range 35, you can say that the data vary from 30 to 65. It's a dispersion measure. Right? Another dispersion measure is the quartile deviation. It's the quartile deviation. So the formula used to calculate the quartile deviation is this. That is, quartile deviation means we need to calculate the Q3 of the data set and Q1 value of the data set. So, and we get the difference and get the divided from 2. Right? This is called as the quartile deviation. So, so when you have the data, you can calculate Q1, Q3 and calculate this value. And what is mean deviation? Mean deviation is the mean of the deviation of individual values from their average. Right? Here, this formula mean deviation is the mean deviation is the mean of the deviation of individual values from the average. From the average value, if we say x bar is the mean, right? If I denote individual values from x, right? Suppose I have the data like this, 2, 5, 3, 4, 6, I have 5 data points, right? I can denote these data points like x1, x2, දෙක කියන්නේ x1, 5 කියන්නේ x2. එහෙම one notation එකක් පාවිච්චි කරොත් x3, x4, x6, right? So I can say mean deviation is I find the value for x bar, that is the mean. This is the mean. So this is the mean of the data set. How I calculate the mean, get the summation of this data and divide from 5. Get the mean. So mean deviation from each observation. If you consider the first one and 2 minus x bar, 5 minus x bar, 3 minus x bar, get the deviation and get the summation of these deviations, absolute value of, with the absolute value of deviations and get the summation over these 5 data points and divide it from the number of data points. We call this as the mean deviation. Right? This formula says it. So for this example, let's see how we calculate the mean deviation value and the mean, find the mean deviation value. To calculate the mean deviation, first you need to find the mean, right? So see, please get 1 minute and for these values, calculate the mean deviation. You have to use the formula, right? The formula, we get the summation of the absolute deviation, but which deviation? The deviation from each individual value from the average. We divide it from the number of data points. Right? This absolute value means we get the positive values or consider the positives only, right? Right, any questions? Right here, how do I calculate the mean deviation? The formula is this. So first I need to calculate the mean x bar value. So I get the x bar. Mean value is 5 plus 6 plus 7 plus 7 plus 7 plus 8 over 5. So it gives the mean 49 over 7, right? It gives the mean is 7. Mean is 7. So then calculate the mean deviation. How I get the mean deviation? Right? 5 minus 7. Get the deviation, absolute deviation from each observation from the mean, right? And 6 minus 7 absolute value plus 7 minus 7 absolute value plus again we have another 7, 7 minus 7 absolute value plus another 7, 7 minus 7 absolute value and 8 minus 7 the absolute value. We get this summation and divide this from number of data points 1, 2, 3, 4, 5, 6. Again, we have another one, right? 9. So we have 7 data points, right? The last data point is 9. 9 minus 7, right? Absolute value. And we divide this whole summation from 7 data points. So what is the value? Right, mean deviation 5 minus 7 minus 2. Right, here within the mod value we have the minus 2. Right, here within the mod value we have minus 1. Here 0. Right, here plus 1. Minus 2 mod value means 2. 2 plus 1 plus 0 plus 0 plus 0 plus 1 plus 2. This quantity divided from 7. Right? So mean deviation is 6 over 7. Any questions? Right, the next, these are very important dispersion measures. It's a standard deviation and variance, right? Mainly we talked about these two. Is the standard deviation means, right? See the formula. This is the formula to calculate the standard deviation. The short form is say ST. What this formula says you, what you can see here, it is the standard deviation is the square root of what, right? Here we this division now, here we have some quantity and we divide it from the total number of data points. Right? So what is this? What is this part? What this within this square term, right? What this says? This says the summation of the square deviations from the center. Square we get the summation of the square deviation from the center for all the values and divide it from the total number of data points and get the square root. We have the standard deviation, right? That is, we get xi from xi value, we subtract the mean and get the square. Right? If we get a negative value, it becomes to a positive one, squared one. Get the square and get the summation for all these, around all these values. I goes from 1 to n, here I, and divide this from n and get the square root. This is we call as standard deviation. right? But this is like a population for the population of data. Population of data, that is for the whole set. But we know that population data, this is this one. But we know that we have the sample data, right? We have sample. We get some subset of the data. So we have the sample data. So we talked about the sample standard deviation. What we do here, instead of n, we have n minus 1. How we define the sample standard deviation? For the sample of values, we calculate the sample standard deviation. This is the square root of x summation of xi minus x bar square values. We divide this from n minus 1, the total number of data points minus 1. We call this the sample standard deviation. The notation is simple S. Right? Here, this is the population standard deviation. We denote this using the notation sigma. Sigma. Right? Here, this is the total number of data points. Right. So now when you have some data points, right, to calculate here, you need to do manual calculations and calculate the standard deviation of the data. So now think about, now you have some data points, you have the 7 data points. So when calculating standard deviation, sample standard deviation value, you need to substitute the values for this formula and simplify. Right? So very easily we can do it by constructing this type of a table. Because here you need to calculate x bar value, and again from each value you need to consider the difference xi minus x bar and get the squared values and calculate, right? So very easily we can do it if you construct this table. That is, you have here the x values and the x values, and x values are 5, 6, 7, 7, 7, 8, and 9. These are the data points, right? So in the formula we have xi minus x bar. So I calculate this column, x construct xi minus x bar column, right? That is 5 minus xi. This is the value minus x bar 7. 6 minus 7, 7 minus 7, 7 minus 7, 8 minus 7, and 9 minus 7, xi minus x bar. Then again, create another column to calculate x minus x bar squared value. Right? So this 5 minus 7 minus 2, the 4 is 1. 0, 0, 0, 1, and 4. Now, when I get the summation of the values in this column, you get summation of xi minus x bar square value. Summation of these values 4 plus 1, 5, 6, 10. Right? This quantity is 10. So, very easily you can get the answer for this. So, the sample standard deviation is the square root of summation of these values, that is 10 over n minus 1. Right? What is n minus 1 here? 10 over n is 7, 7 minus 1, 6. This is the standard deviation. Any questions? Right, then what is the variance? Variance is the square value of the standard square value of the standard deviation is we called as the variance, right? So sample variance is S, and the variance notation is the S square, right? So population variance is sigma square. For this example, for this data, the variance is, right, for the above data, variance is the square value of the sample standard deviation. That is, the sample standard deviation is 1.29 squared. The value is 1.67. This is the variance of the data. That is like the variability of the data. It gives some measure. It gives some measure about the variability of your data. Okay. Right. So now we talked about, right? We discussed about some graphs, and we can to summarize the data, we can draw some tables, right? And also we can calculate some summary measures. Under summary measures, we discussed about the measures like we talked about the center and some location like mean, median, and mode, right? And some location measures like percentiles, right? P10, P25, right? And quartiles, Q1, Q2, Q3, like these location measures discussed under summary measures. And also, now we know under summary measures, when we summarize the data in a variable, you can talk about the center of the data, that is the central tendency measure, as well as we can talk about what is the dispersion of the data, right? So under summary measures, we discussed about some dispersion measures, dispersion of the data. What are the measures we used, right? Mainly use range, standard deviation, and variance. Other than that, we can calculate mean deviation, right? Quartile deviation. We discussed about this. So these are the main ways we can summarize your data under variables. So this is another measure. This is a very important measure in some situation, that is coefficient of variation. Coefficient of variation, right? So please read these points and try to understand. The formula we use for the coefficient of variation is this. For the sample data, it is this, right? Please read these points and understand what this measure says. It's also some dispersion measure. We can talk about the dispersion, but it's not a, it's a relative dispersion, relative variation, relative variability. CV measures the relative variability. Okay? So please go read these points. What this measures is, this represents the ratio of the standard deviation to the mean, right? In the formula, you can see CV, coefficient of variation. In short form, we write it as CV. CV is equal to S sample standard deviation over sample mean, right? It's the ratio of the standard deviation to the mean. Right? And we can present this value as a percentage value also if we multiply it by 100. Right? So it is useful for comparing the degree of variation from one data series to another. If you want to compare the variability of the two data sets, right? In some situations, we have to use this. The very important case is especially when comparing the variability of two or more data set measured in two different units. Right? You know that now suppose we have one data set measured in one unit A. Then we can calculate the standard deviation. Suppose you have the data measured in kilograms. The dispersion measure, if we calculate the standard deviation, the your answer, you will get some answer. You can calculate some numerical value, and that value also has some unit, right? It has kilograms. So when we talked about the variance, it is a square kilogram, right? So suppose you have another data set, it records in a different unit, right? Now you have to compare the two standard deviation values and say which data set has the high variability, high dispersion. If the two units are different, we cannot do it, right? So in that case, mainly we use this measure, that is coefficient of variation. It is a unit-free measure. Unit-free measure. It has no any units, right? Because standard deviations, we have a unit. Suppose for the data measured in kilogram, it is recorded in kilogram. So example mean, again, it is kilogram. So when you calculate the CV, the units cancel out, right? So now go through this example, read this example, and here you have the solution also, but read this example. It asks you to calculate the CV and compare the variability. Try to understand. You have two variables measured in two different units, and you are asked to compare the variability of the two data sets. Variability of the two data sets. Right? Then how you compare the variability of the two data sets? You cannot do it here using sample standard deviation. So variance is so square. You have to calculate coefficient of variation. Right? Get 1 minute and go through this question and write down the values using the notations and calculate the CV. And first you need to calculate sample standard deviations, these values, right? I think all these values are given here, but using the standard notations, you can write down, right? You can write down using standard notations and calculate the CV. Any questions? Can you, do you have any questions? So can you do this? Yes, I will upload I will upload last time question paper, right? So then you can practice it. And also please please complete the questions in the tutorials, right? You can go through the last time paper also. Other than that, please complete the tutorials I will upload. Right, I will upload another tutorial tomorrow based on this, the things we discussed. Right, so please complete those. The question paper will consist with the similar types of questions in your tutorials. And also you can try to do the past exam paper. Right, so this question, right, read the question. Measurements on yield and plant height of a paddy variety are given. Right, you have given some measurements on yield and plant height. Yield and plant height were given. The mean standard deviation for yield are 50 kilogram, right? You have given, now you have, can you understand here? They are talking about two variables. What are the two variables here? What are the two variables? Regarding some paddy variety, they are talking about the measurements, some measurements on what?
Yield and height.
Yield and plant height, right? These are the two variables here. So I have the data for the yield, I have some data and plant height, right? So now you can see if we say yield, it measured from the units kilogram, and if we talked about the height, right, here height is measured from centimeter. These are the two different units, right? So now summarize the given values. The mean and standard deviation for yield are mean value x bar. In notation, mean is x bar, right? This is the mean. And standard deviation, sample standard deviation value, simple S. What are the values given here? For the yield, 50 kilogram, and the standard deviation, 10. The mean and standard deviation for plant heights are 55 and 5. Right? So these are the given information, and you are asked to compare the variability of the data in two variables. Here you have two variables. We want to compare the variability of the data in the two variables. Right? Here, the next important point is you have the standard deviation. Standard deviation means we use standard deviation as a dispersion measure. Talked about the variability, you can use this, right? Here one data for yield data, variability is 10. In height data, variability is 5. But you cannot compare these two variabilities values 10 and 5 because those two are in two different units. This is from kilogram, this is from centimeters. Two different units. So you cannot say that yield is high variability than plant height. We cannot say like that, right? Yield has high variability than plant height. It is wrong because These two has two different units. So what is the measure you need to calculate is the coefficient of variation, right? For these two cases, you need to calculate the CV. So how we calculate the CV? Right? How we calculate the CV? To calculate CV, what is the formula? CV is S over X bar times 100. Right, this is the formula, S over X bar times 100, right? This is for the population. When you have the population data, we can, if you can have the population of data, you can calculate it. But normally we have sample. So CV is this. So CV, if I say CV1, this is S is 10 over X bar 50 multiplied by 100, right? The second one, CV2 is 5 over 55 multiplied by 100. So we get the values. First one, CV1 is 20% and CV2 is 9.1%. So it is unitless, no unit, because the units are cancelled out, right? So now you can compare these two values and say which variable has the high variability. So here, according to this, the yield has more variability than plant height data. Yield has more variability. Any questions? So it's a relative measure, right? Relative to the X bar something. Now we talked about the dispersion relative to the mean center. We get the dispersion relative to the center in each variable, under each variable, and get the measure without units. Now you can compare these two measures and talk about the variability. Any questions? So then next one, this is note number 3 and note 4. We need to talk about the probability and some probability concepts and some probability distributions. So up to here, we talked about how we describe our data, how we do the descriptive data analysis. What we have done here, we discussed about several graphs, some tables, and some summary measures, like measures like coefficient of variation, mean, median, dispersion, measures like range, standard deviation, variance, right? We talked about some measures and graphical outputs and tables. All these things we can say we describe our data. We describe the data for some variables, right? We can use those things. Now we are going to talk about another concept in statistics, right? We call it as the probability theory. Probability theory and some probability distributions. Probability distributions, right? So there are a lot of probability distributions, but we need to talk about very important and commonly used probability distributions on the like binomial probability distribution, Poisson distribution, and the normal distribution. Out of these three, also normal distribution is very important. Okay? So now see what you can see in this slide. And please go through the things. And see here, it talks about some events. Here it shows you some events. The sun will rise. When we toss a coin, we will get a head. And rolling 2 dice, right? It discusses about some events. When rolling 2 dice, getting 14. If we roll 2 dice in a one die, we know it has 6 sides. 1, 2, 3, 4, 5, 6. Like this way, I select 2 dice and roll. Right? So I can get in one die, if I get 7, and in the other die, sorry, in one die if I get 6, and in another die I can get 5. In both dice also I can get 5 and 5 as the faces the top. Right? If we roll the dice, 2 dice, and if we toss a coin, sometimes we can get a head, or sometimes we can get a tail. Right? So these are some events. Some events in day-to-day life. We can find this type of events. Right? Many events in our life are uncertain. We cannot say exactly what will happen. If we toss a coin one time, I cannot say what I get, but I can say there are only 2 options. I can get a head or tail, but I don't know what will happen. Right? But if I say the sun will rise like the event, this is exactly happen. We know the sun will rise. But getting ahead, if we toss a die, getting ahead means some event happens. Some event happens. Right? So if we use a fair die, if we use a fair coin, if the 2 sides of the coins are equal, right? There is no bias, fair coin. There is equal chance of getting head or tail if we toss the coin. When we toss the fair coin, there is an equal chance, even chance. There is an even chance of getting the side head or tail. Then what can you say about this event? Rolling 14, number 14. If we roll 2 dice, getting number 14. Can you get this event? If we roll 2 dice, can you get number 14 as the total of the 2 faces? Get as the top? සමහර දේවල් තියෙන අපි මේ ඉවෙන්ට්ස් කියන්නේ යම් සිද්ධීන් සමහර සිද්ධීන් නිශ්චිත වශයෙන්ම සිදු වෙන්න පුළුවන්. සමහර සිද්ධීන් සිද්ධ වෙන්න පුළුවන් එක සමාන chance එකක්, equal chance එකක් තියෙනවා. Right? සමහර සිද්ධීන් කොහොමදවත් වෙන්න බෑ. It is not possible. So if we roll 2 dice, 2 pair dice, getting 14 is not possible. Right? For the 2 faces, we can get some values for the 2 faces. The maximum values goes up to 6, so 6 and 6. So we cannot get the total as 14, so it is not possible, impossible. It's an impossible event. But this event is certainly happen, certain event. This is also can happen with equal chance. So we can say that for this side, we say there is a more likely to happen in this event. There is a high probability to happen in this event. Right? For this side, we can say there is a more unlikely to happen in this event. There is a less probability, less chance. Right? So what is the definition of the probability? Right? Please go through these points, and after that I will explain. The probability is a measurement tool that calculates the chance or likelihood of occurrence of an event. It talks about the likelihood or occurrence of some event. or chance of happening an event, or likelihood of happening an event. We call it as the probability. So the chance is expressed, we talked about this chance, it is a value in between 0 and 1, right? It cannot be a negative value, or it can be 0, or it can be 1, cannot be a negative value, or cannot be greater than 1, right? With the chance being 0, 0 means possibility of the occurrence of the event is, there is no possibility. Right? With the chance being 1 means they exactly happen. The possibility of the occurrence of the event is certain. It is certainly can happen. Right? And the higher the chance, that is the chance higher means the higher probability, higher possibility of the occurrence of that event. Right? So by talking about the probability, we talked about the chance of happening something. Can take 0, it can be 1, and any value between 1. So, when we talked about the probabilities, right, we have talked about some terms like events and outcomes of some experiments, right? So we know this one, a random variable is a variable, it can take different values. The values of the variable depends, the values of that random variable can depend some chance or some probability. Right? So we know what is a discrete random variable. So a discrete random variable means it's a variable, it can take some finite number of values, right? And which do not take all the values in a particular range. So can take only discrete values only. See, 20 coins are tossed, right? So suppose that I toss 20 number of coins, pair coins. So then the number of heads we obtain, I can say that this is a random variable and it is a discrete random variable. It's a discrete random variable because it can take discrete values only. We toss 20 coins, right? But select the coin 1, coin 2, coin 3, like this. Suppose I have 20 coins and I toss these 20 coins and I define a variable. My variable is based here, I do some experiment. What is my experiment? I toss a coin 20 times, toss a pair coin 20 times. So I define a variable as number of heads obtained. So this variable, number of heads obtained, I can use in English letter, I can write this way also, capital X equals the number of heads obtained. Then what are the values this variable can take? It can take different values. What are the values this the X can take? Can you tell me what are the values this X can take? If we toss a pair coin 20 times, number of value, the number of heads we obtain. If we define the number of heads we obtain as a random variable X, what are the values that X can take? Think about and give me some your answers. What are the answers? What are the values we can get for head x?
1 to 20 numbers of
Sorry, from this number 20.
1 to from 1 to 20.
From 1. Okay, it's not completely correct, but you're good, right? Because we can get these values like we can get 1, right? And 2, 3, and we can get 20 number of 20 heads also. If we get 1 head, 2 head, 3 head, in 3 coins, suppose we toss 20 coins out of 20, right? All the coins will give heads. Times all the coins will give tail, right? Then this starts from not 1, starts from 0. The number of heads we can obtain, this random variable can take the values from 0, 1, 2, 3 up to 20. These are the values that the variable can take. Right? Any questions? Is it correct? And because if we toss, this is the coin, first coin, right? When I toss the coin, I can get head or tail. I don't know what will happen. These two possibilities, even chance, equal chance of getting a head or tail, right? If we toss the second coin also, equal chance of getting a head or tail. Third coin also, equal chance of getting a head or tail. This one also, last one also, equal chance of getting head or tail, right? So when we toss 20 coins, sometimes if all the coins give heads, right, then the value 20. If all the coins give tail, the value 0, and any other value, discrete value in between these two, we can get the values as the random variable x. Only discrete values. Right? So we can define a discrete random variable as this way based on this experiment. Right? Now we are going to talk about the chance of happening these values. What is the chance of getting 0? 0 heads if we toss 20 coins at a time. What is the chance of getting 3 heads if we toss 20 coins at a time? Right, like this way. Now, what we are going to do here, we are going to talk about the chance or probability of happening these events. Probability of happening these events, right? The basic difference between the continuous variable and the discrete random variable. You know what is a discrete random variable and the continuous random variable. In a discrete random variable, we have like discrete values. You can get only discrete values. Continuous random variable, for an example, suppose random variable is the student's marks. Student marks can take 0, 100 or any value, infinite number of values in between these two. But when we look at the data set, we can see only discrete values, but it's a continuous variable. Right? So here, regarding these two random variables, the random variable can take different values. Right? So I said we are going to talk about the probability or chance of getting these values for this case and for the continuous case, discrete and continuous case. In these two cases, you can see the number of values it can take. Here it is discrete, here it is continuous. So two types of probabilities we can discuss. right? For discrete variable, the probability of taking any particular value is defined. I can talk about what is the probability of getting 0, what is the probability of getting 2, what is the probability of getting 20, like that. But if your variable is a continuous one, we cannot talk about the discrete points, probabilities of discrete points. We talked about the probability only for the range of values, interval of values. Probability of the marks in between 20 to 40. The probability of getting marks in between 20 to 40. Right? Like that, we can talk about the range of probabilities in continuous scales. Okay, any questions? Now read another two terms. When we talked about the probability, you need to know about these two terms. That is the sample space and event. Please go through these things and read these examples and try to understand what I am going to talk about here. The sample space is the set of all possible outcomes of an experiment. If we conduct some experiment, the all possible outcomes of an experiment we call it as a sample space. Right? For an example, if we toss a coin, the sample space, right, as the outcome, what we can get a head or we can get a tail. So this is the possible outcomes we can get if we toss a coin. So how we write the sample space using some English, you can use some English capital letter, and you have to write the sample space within curly brackets. In curly brackets, you can write down what are the all possible outcomes of this experiment. This is called as a sample space for this experiment. Right? Suppose another experiment, if we toss a coin 3 times. So I think about, I have 3, toss a coin, I toss this coin, right? I toss a coin 3 times. I toss a coin, I have 1 coin, right? This coin, if we toss the coin 1 time, I can get head or tail. Right? Then I toss this coin 3 times. This is the first time. If I toss the coin first time, I can get head or tail. Then how I find the sample space? What is the sample space? What is meant by sample space? Means all possible outcomes of this experiment. All possible outcomes of this experiment. Right? So this is the sample space of if you toss a coin 3 times. Right? The third one, throwing a 6-sided die. Suppose you have a die, it has 6-sided, equal size, 6 faces. Right? When I throw this die, what will be the all possible outcomes? All possible outcomes can be 1, I can get 1, 2, 3, 4, 5, 6. Right? These are the all possible outcomes. This we call as a tree. These are 6 sample points. But in the second one, right, if we toss the coin first time, you can get a head or tail. Right? Here we toss the coin 3 times. Then again, the second time also I toss this coin. The first time I get a head. In the second time also, there is a chance of getting head or tail. Here the first time I get a head, and in the second time also we can get head or tail. Here the first time I get a tail, then the second time also there is a chance of getting head or tail. Right? Then I toss the coin 3 times. Right? 3 times. The third time, the first time I get a head, the second time so I get a head, and again I toss the coin. Again I had a chance of getting head or tail. Right? Here I toss the coin. First time get head, second time get tail, and again I toss the coin. We can get a head or tail. Right? Here first time I get a tail, the second time I get a head, and the third time I get a head or tail. Right? And the first time get a head, second time get a tail, second time get a tail, and the third time also I get a head or tail. Right? Now the chances are over. I toss the coin 3 times. Toss the coin 3 times. So this is the experiment. This is the experiment of my signals. So what are the sample space? So the all possible outcomes are these. Right? How do I identify these all possible outcomes? Right? Or what are the all possible outcomes? Right? All possible outcomes. How I write? How many outcomes are here? 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes are here. We can find when we go through the bar, when we go through these bars of these trees, right? These tree branches of these branches of the tree, right? This branch, from this branch, get a one outcome. From this branch, I get the second outcome. This branch, I get the third outcome. This is the fourth outcome. This is the fifth, sixth, and the seventh, and the eighth outcome. So I get, right? First time I get head. In the second time also I can get head. In the third time also I can get a chance getting head. Here, the first time I get head, second time I can get head, and the third time I get a tail. Right? Here, all the 3 times I get tails. Is it clear? So these 3 examples gives you the all possible outcomes or the sample space for your experiment, random experiment. Right? Random experiment. So what is an event? Based on this sample space, we can define some events. An event is a subset of the sample space. Event is one. Event is a subset of the sample space. Right? The event of getting 4 in the die. Capital A is the event of getting 4. I define an event as A. I define capital A is an event. Answer. things we use in event operator when talking about the probability. Right, so let's say capital A and B are two events, and capital S is your sample space. Capital A, B are two events, and capital S is the sample space. Right, so here you can see in the first diagram, you have the sample space and you have two events A and B. Then the intersection of these two events are marked as blue. Right? We call this as the intersection. Intersection area of these two events. Right? This one, I have the two events A and B, and the yellow colored area shows the union of these two events. Union, the common. This is the common area. This is the both the whole unit belongs to A and B. All the units belong to A and B. This is common, like intersection, common to A and B. Right? This is the marked area we called as A union B. How you used in the notation, we can write it. This union notation, we use this symbol union, A union B. Right? Here intersection, to denote the intersection, we use the notation this intersection A intersection B. So A intersection B means this marked area intersection, right? A union B means this yellow color area, right? And this is event A, and the element does not belong to A. This pink color area shows as the complement, A complement, A superscript simple C, A complement. Or we can write it as A bar or A dash, right? Or A complement. The same thing says from this notation. Complement of the event, right? So this here also it explains clearly complement of an event, right? We denote A bar, A dash, or A complement, right? And here the A union B, shaded area A union B. If we say the event A, the complement of event belongs to this, shows this whole area, right? The complement of B, complement of B means this is the event B, the whole area does not belongs to B is the B complement, right? And this common area, this whole area shows the A union B, right? And this is the intersection area. So the difference between the two events, right? Difference between the two events means A minus B, or we say this as the A intersection B dash. A intersection B dash mean, how I find this, right? I draw the sample space and I have two events A and B. What this notation says, A intersection B complement. A intersection B complement. So how we find it? First I mark A. This is the area belongs to A. Then this is A and B dash. B dash mean B complement. B complement or B dash mean the elements, the area does not belongs to B. Then what is that area? Area does not belongs to B means this area I colored using this blue color. This is the area does not belongs to B. Right? The red color shows you the area belongs to A, and the blue color shows you the area belongs to B dash. Right? The red color shows you the area belongs to A. Then what is the intersection area? What is the here? The we need the intersection. What is the intersection area? This one, A intersection B dash is what? What is A intersection B dash? Here A intersection B dash means another, in some books we can see, we can write it as A minus B, right? In some statistics or mathematics books, right? It written as this way also, A minus B. The meaning of this is A intersection B dash. Then what is the area belongs to A intersection B dash? Which area?
Only A area belongs to A.
Not A. Here, the intersection of common area for intersection means means some common area for A and B. Right? Here I want to find the common area for A and B dash. Common area for A and B dash means, right? A and B dash means this. Common area for A and B dash means this shaded area only. This does not belong to A intersection B dash, right? A intersection B dash mean A, right? The common area for A and B dash. This area belongs to A, but it does not belongs to B dash. It belongs to B, right? So this orange color area is the A intersection B dash. Right? Always, if we say intersection of events, right? Intersection of events means A intersection B means, how I identify it? A intersection B. A means A is this whole area, right? But some part belongs to B, and B means B means this one B. So you have both colors in this area, both colors we have this area. This is the A intersection B. That means this area shows the common elements to both A and B. The elements in this area belongs to both A and also B, right? This is the intersection. And this is the intersection of A and B dash, A minus B. And if we say the union means it belongs to A and B both, right? This is A, this is B. So union means this is A, and B means this is B, right? So A union B means all the elements belongs to A and B both. A or B or both. Right? This whole shaded area called as the A union B. Is it clear?
Yes, madam.
Okay. Right. Now, for these two examples, right, you can do this example 1.2 as a homework, but this one, example 1.1, for this one, first it has to calculate the probability, but to calculate the probability, you want to know about the next theory parts also, right? Before calculate the probability, now for example 1.1, what I want to do is for this experiment, first write down what is your sample space, right? What is your sample space, and write down the elements belongs to these events, right? Suppose in the question it asks two heads. So suppose that using capital A English letter, I say the event of getting two heads, right? And I use capital B letter to denote the event of getting two tails. Capital C I use to denote the event of getting a head and tail, right? Capital D I use to denote the event getting at least one tail. Right now you have five English letters. This is the standard notation for the sample space, capital S. For this event, to denote some event, you can use any capital English letter, right? So now what I want to do for this experiment, write down the possible values for the sample space and these defined events. Write down the possible values. Right, we can stop the lesson at 1 p.m., right? We complete this example and stop the lesson, and after that, again, you can join to the meeting at you can get a break, 45 minutes break, and join the meeting again at 1:45, right? So first we complete this one. Right, what is this experiment here? A coin toss twice, right? You have one coin, you toss it 2 times, right? You are asking to calculate the probability of happening these events. If we toss a coin 2 times, suppose it's a unbiased coin, right? So you need to calculate the probability of getting 2 heads, 2 tails, a head and a tail, and at least one tail. before calculate the probability, first you need to identify what are the elements you have under each event, and what is your sample space. Right? What is meant by the sample space? Sample space means the all possible outcomes if we conduct some random experiment. So here, what is my experiment? I toss a coin twice. Right? When I toss a coin 2 times, right? Suppose in the first time, when I toss the coin, what will be the outcomes? I can get a head or tail, right? This is the first time. Then in the second time also, I toss the coin. If I get a head in the first time, then there is a chance of getting in the second time also, I get a head or I get a tail. Right? If we toss the coin first time, there is a chance of getting tail. Right? There is a chance of getting tail. In the second time, first time I get a tail. In the second time also I can get a head or tail. So now you can write all possible outcomes. Right? The sample space S is, right, going through these branches. Right? This one, and this one, and this one. You can write down the all possible outcomes are H. This is one outcome. That means first time you get a head and the second time you get a head. Or first time you get a head and the second time you get a tail. Right? First time you get a tail and the second time we get a head. And the first time we get a tail and the second time we get a tail. So these are the all possible outcomes. Right? Now write down what is A, B, C, D. A is the event of getting 2 heads. What is the event of getting 2 heads here? What is the event of getting 2 heads? So what are the outcomes? Belongs to event A. When writing the elements belongs to event and the sample space, you have to write it within curly brackets. Using you can separate the events, right, using comma, and definitely write it using you should write it using within curly brackets. So what is event A? The event of getting 2 heads. If we toss the coin 2 times, the event of getting 2 heads means 2 times we get head. That is, when you get this event, that means the 2 times getting 2 heads. Event of getting 2 heads. So B is the event of getting 2 tails mean 2 tails we get when the first time we get tail and the second time also we get tail, then you can say that is the event of getting 2 tails. Right? So C is the event of getting head and a tail. How many outcomes are there? How many elements are there for this event? The event of getting head and a tail. The event of getting head and a tail means event of getting head and a tail. If we get this outcome or this outcome, the represent event of getting head and a tail, head and a tail, head, tail, and a head. Right? So C means if we get these outcomes, head, HTOTH, right? These are possible outcomes. This one or this one, I don't know. I have to consider all possible outcomes. So these are the 2 elements belongs to this event. So D is the event at least one tail. At least one tail means we can have at least one tail means one or more than one. One or one tail or more than one tail. More than one tail, right? So for the event D, the event D can happen when at least more than one tail. At least more than one tail means if we get this outcome, is one tail. We get this outcome, one tail, right? We get this outcome, two tails. That is at least more than one tail means all these three elements are belongs to have all these three elements. That means if any one of these elements outcomes happens, that means the event D happens. Right? So these are the sample space and the possible outcomes for these events. Right? Any questions? Any questions? So
No, ma'am.
we can talk about the probability, how we find the probability, right? So this is just you need to calculate this. You need to write down these events, right? So as a homework, you can complete this one, write down the sample space and the possible outcomes. For example, 1.2. Right? Right, under probability, there are several probability axioms, right? So probability, we say probability of some event, always how we denote it. Probability of event A, we denote it as using capital P A, right? Or you can use this notation. So P simple R, probability of event A. Right? Always it can be 0 and it can be 1 or any value in between 0 and 1. If we calculate a probability of some event, it cannot be a negative value. It cannot be greater than 1. Right? It can be 0, 1 or any value in between 0 and 1. Right? Is the rule 1, and the rule 2 is the sum of the probabilities of all sample points throughout the sample space, right, must be equal to 1. Or the summation of the probabilities for the all sample points for the sample space should be equal to 1. So how we calculate the probability, right? There are several ways to calculate the probability. We can discuss this one. Suppose if E is the sample space of the experiment and S is the subset, right? Suppose E is the sample space for the experiment and here it uses the notation S for the subset of it, and E and all sample points are equally likely to occur, right? All the sample points are equally likely to occur, then the probability of occurrence of the event is, right? Here, instead of if it is, if you like, you can change this, right? E and S values, like here, suppose if capital S is the sample space of an experiment, and if we say capital instead of S, write down A, right? A is the subset of S, and all sample points are equally likely to occur, then the probability of occurrence of event A, right, PA, we can write it as NA over NS, right? Here, instead of S, write down A. Please correct this one, right? I think otherwise you will get difficulty in understanding, right? Instead, because we use capital S notation to denote the sample space, no? Right? This is actually in your course manual as this way, but I think if you change these values, E as S and S as A, you will get it is easy to understand, right? So probability of happening event A, we can calculate using this. What these values say? NS, NA, and NE, right? Here, NS means NS and NA, right? Here A, right? NA means number of elements in event A, right? NS means the number of element in the sample space, right? So how we calculate the probability of event A? By getting these two. That is, you need to find out the number of elements in event A and the number of elements in the sample space, and we can calculate the probability of event A. Right? So now example, for this example, you have the answer also. So we can get the break, right? In the break, you can try to answer this question. A fair die is tossed one, right? A fair die is tossed at one time, and find the probability of getting an even number and number greater than 2. Right? Please go through this example and first write down your sample space and write down these two events, the elements for these two events, and try to calculate the probability using this. Right? So you have the answer, but please don't go through the answer, and first try to answer. Try to go through what we have discussed up to now, and how we calculate the probabilities, how we write down the sample space and event, and try to write your answer, right? And in the next session, we can discuss about it. Now I stop the meeting now, right? Please join again at 1:45, right? I will send a new Zoom link, right? I will send a new Zoom link and start the lecture again at 1:45. 1:45, right? So any questions you have, I will upload. Please go through the tutorial, and I will upload another tutorial also, and you have an assignment, right? For this, I think your exams is on 21st, right? You have the exam paper on 21st, and you have to complete your assignment, and you have a quiz also, LMS quiz, right? Very simple questions. I will upload this one in this week. So you have to complete the quiz and also complete your assignment, and you need to hand it over to the department when you come to the exam. Right? So you have several practice questions. I will upload my tutorials and last time past paper. Any questions? ඔයගලන්ට assignment එකක් වෙනම තියෙනවා. ඒ assignment එක කරලා ඒක මම අප්ලෝඩ් කරන්නම් Monday වෙනකොට. ඒක කරලා exam එකට එද්දි බාර දෙන්න. LMS එකට quiz එකක් දානවා MCQ. ඒක complete කරන්න. Tutorials දානවා. ඒව submit කරන්න ඕනේ නැහැ. Tutorials වලට ඔයගොල්ලෝ තනියෙන් try කරන්න. Questions තියෙනවා නම් මට message එකක් දාන්න, right? නැත්නම් WhatsApp message එකකට email දාන්න. හරි. නැත්නම් call කරන්න. Right. Any questions? Right. If you have no questions, I stop the meeting. Right. Please join again at 1:45. Right. Thank you. A fair die is tossed one time and find the probability of getting even number and a number greater than 2, right? So what is your experiment here? Random experiment is a fair die tossed one time. If you take fair die tossed one time, right, now first you need to write down what is your sample space. What are the elements? What are the all possible outcomes? What are the all possible outcomes for your sample space? All possible outcomes are 1, 2, 3, 4, 5, and 6. These values only. When you toss a pair die, right, we will get these values on. Right, this is the sample space, so you can use capital S notation or capital E. It's not no difference, but most probably to denote the sample space we use capital S, right? So this book it use capital E, right? It doesn't matter, right? So now it asks and what is the probability of getting an even number, right? So we want to find this probability question. Part 1, probability of getting an even number, right? Probability of getting an even number means, first I want to identify what are the elements belongs to this event. So I define this event, getting an even number, as capital A. If I define the event as capital A, what are the elements belongs to capital A? Getting an even number, we get an even number if we get 2, if we get 4, or if we get 6, right? So the elements belongs to event A is 2, 4, and 6. So then very simply, right? This is, you can calculate probability of getting an even number is the number of elements in A, number of elements in event A over number of elements in event in sample space S. So here it use capital E, right? Okay. So now substitute number of elements in capital A 1, 2, 3. Number of elements in the sample space 1, 2, 3, 4, 5, 6. 3 over 6. This is the answer. Okay. And the second one, a number greater than 2. Second one, a number greater than 2. That is again for this event. If an event of getting a number greater than 2 is B, we define capital B as the event of getting a number greater than 2. Event of getting a number greater than 2. So what are the elements belongs to event B? We get a number greater than 2, right? If we get these values, we get a number greater than 2. 3, 4, 5, 6, right? 3, 4, 5, 6. If we get these values, we get a number greater than 2, right? So then the probability of B is equals to NB over NS or NE, right? NB is 3, NB is number of elements 3, 4 over 6. This is the answer. Right, so you will get very simple questions from the probability. So please practice these things, right? Any questions? Now, we want to talk about some very special types of events, like what is mean by mutually exclusive event, and what is mean by an independent events, right? These two we need to talk. What is an mutually exclusive events, right? Here, see this example and this diagram, right? You can see we have the rectangle we use to denote the sample space, and on the sample space we have two defined events, A1 and A2. Two events. To denote the two events, I use two circles. Right? So now these two events, I can say that these are mutually exclusive events. A and C. Right? Two events are mutually exclusive if they cannot occur at the same time. They cannot occur at the same time. We can say those events are mutually exclusive. An example is tossing a coin one time, which can result either heads or tail, but not both. Right? So when we toss a coin at a time, we head or tail both. Right? So in this experiment of tossing a die, if you consider the experiment of tossing a die once, right? If we roll a die one time, the event of getting each number is considered as mutually exclusive event. Event of getting each number, getting 1, 2, 3, 4, 5, 6. These events are mutually exclusive events, right? When we get 1, we cannot get 2. Right? When we get in the event, when we get in 3, we cannot get 4 or 5, like that. There are 6 events, the 6 events, those are mutually exclusive, because only one of these events can occur in a single trial. In a single trial of the experiment, when we roll the die one time in a single trial of the experiment, we can get only one value. We can get one value of only out of these 6 values. We cannot get 2 values at a one time, right? So all these events are mutually exclusive. For an example, suppose your sample space is 1, 2, 3, 4, 5, 6, and you have 3 events defined here. Event A, the number it has 2, 4, 6. Event B, 1, 2, 3 values. Event C, 3 and 5. So when we draw this, it says that A and B are not mutually exclusive. A and C are mutually exclusive. How we identify it? To identify this thing, this statement, two statements clearly, right? A and C, right? A and C are mutually exclusive, right? A and C cannot happen at one time, right? A means 2, 4, 6, C means 3 and 5. But A and B are not mutually exclusive. When we A and B, there are common items also, so they are not mutually exclusive. Right? So we can identify this by drawing this diagram. Right? Draw the sample space, and we have 3 events. Draw this diagram. We call this diagram actually in O-level mathematics, we call this diagram as the Venn diagram. Venn diagram. Venn diagram, right? අපි කුලක කියලා ඉගෙන ගන්නේ මේ කුලක කියලා ඉගෙන ගන්නවා O levels වලදී ඒ වගේ පොඩි කොටසක් තමයි මෙතන තියෙන්නේ. හැබැයි අපි probability ගැන කතා කරන්න යන්නේ ඒත් අපිට sample space, මේ events, එතකොට මේ කුලක වගේ තමයි මෙතන basics වෙලා තියෙන්නේ. Event A 2, 4, 6 and event B 1, 3, 4. If I draw event A and event B on this sample space, right? Event A and B, it contains a common element 4. So I can draw this as this way, 4. Suppose this is event A, 2, 4, 6. Event B, 1, 3, 4. Event C, for event C has 3 and 5 only, right? Only 3 and 5. 3 and 5. So I can draw another circle, right? 3 and 5. So then you can mark the events. right? This is A, and this is B, and this is C, right? So A and C are mutually exclusive, and A and B are not mutually exclusive. They are common elements, right? So this is mutually exclusive events and independent event. Independent events means the two or more events said to be independent if the probability of occurrence of any of these events is not changed by the occurrence of any other remaining events. Right? There is no any dependency from another events to an occurrence of the other event. In the experiment of tossing a die 3 times, right? Suppose I toss a die, In the first time when I toss the die, what are the possible outcomes I can get? 1, 2, 3, 4, 5, or 6. These are the possible outcomes I get. The event of getting 2 in the first toss. This is the first toss. Event of getting 2 in the first toss. The event of getting 4 in the second toss. Right? In the event of getting 4 in the second toss is here, second toss. And the event of getting 6 in the third toss. In the third toss, getting 6 and getting 4, and here getting 2. These are independent events because since the probability of one event is not affected by the other, right? So getting 2 is not, the probability of getting 2 is not affected by the probability of getting 4 in the second toss. Right? So not totally independent. But there are some events, practically there are some events that we cannot say that they are independent. Right? So we are not going to talk about more details. I want to show you another important relationship in the probability, that is if A and B are any two events, right? If A and B are any two events, here A and B are any two events, we can write down the probability of A union B. This is a rule, right? A union B, how we write? It is the probability of A plus probability of happening event B minus subtract probability of A intersection B, right? For any A, B two events, we can write this. For any A and B, this is true. You can directly use this one for any A and B, right? That is, we calculate the probability of A and probability of B, and if there is a common area, we have to subtract, because when we calculate the A, this is we write this one time. When we calculate B, again we consider this another time. So to calculate this probability A union B, we have to subtract this part, common part, one time. Right? If A and B are mutually exclusive, what will happen if A and B are mutually exclusive like this, right? No common area. So this goes to no common area. That means A and B are mutually exclusive means here there are no elements. A intersection B is equals what? If A and B are mutually exclusive, what you can say? A intersection B, this is what? How many elements are there? If A and B are mutually exclusive, no intersection, right? And means no any elements in the intersection is. So this is the null set. This is null. This is 0, null set. To denote the null set in O-level mathematics, we use this null set. A intersection B is null, right? Then when you calculate the probability of A intersection B, there are no any elements, it is 0, right? So when A and B are mutually exclusive, probability of A union B you can write as PA plus PB. If you know this one only, that is A and B mutually exclusive, right? And for the 3 events, suppose you have A, B, C 3 events, we can write this, the union of 3 events as the summation of these probabilities. And under the probability theory, right, before going to talk about the probability distributions, under probability theory, only 2 important rules we can discuss, that is the addition law of mutually exclusive events, addition law of the probability, and the multiplication law, right? And addition law of the probability, right? Please go through your course manual also. I got several points from the course manual. So it is very important to go through it and complete the questions, right? Then you can get some practice. If P1, P2 up to PR are separate probabilities of occurrence of R mutually exclusive events, right? Here, 1, 2, 3, up to R number of, you have R number of events, all are mutually exclusive. The probability that any one of these events will occur in a single trial. In a single trial, the probability of any one of these events occur is the summation of these probabilities. We call it as the addition rule. We add those probabilities. Right? When the die thrown once, when we roll a die one time, right, the probability of getting 2, the probability of getting 2 is 1 over 6. How can I say it is 1 over 6? Right? 1 over 6 because getting 2 means if we roll a die, what is the sample space? We can get 1, 2, 3, 4, 5 or 6. Right? There are only 6 possible outcomes. Out of 6, we get 2. 2 is only in one time. So 1 over 6 is the answer. The probability of getting 4 also again, probability of getting 4 again 1 over 6. Probability of getting 6 again 1 over 6. Right? So for R mutually exclusive events, the probability of any one of these events will occur in a single trial. This we can like probability of getting 2 and 4 we can find by getting the summation of adding these 2 probabilities. These 3 events are mutually exclusive. So like probability of, suppose you want to find out getting 2 or 4 or 6, right? Simply get the summation of these 3 probabilities. You can find the answer 3 over 6 because all these events are mutually exclusive. So this is called the addition law. So A and B are mutually exclusive. A union B we can get by A and the summation of adding PA and PB. They are mutually exclusive. Then multiplication rule means multiplication law. P1, P2 up to PR are separate probabilities of occurring R mutually exclusive events. You have R mutually exclusive events, right? And their probabilities of occurrence are P1, P2 up to PR. Then the probability that all these events will occur in a single trial. Probability of all these events occur in a single trial is the multiplication of these probabilities, P3 up to PR. You can get the idea by going through this example. Please read this example, this one. Right, what this is. When a fair coin is tossed twice, right? Fair coin tossed twice. That is, if we toss the coin first time, we can get head or tail. 2 times, so again we can get head or tail. Here we can get head or tail. So the possible outcomes H, T, TH, TT, right? How I read this, first time I get a head, second time I get a head. First time I get a head, second time I get a tail. First time I get a tail, second time I get a head. First time I get a tail, second time also I get a tail, right? These are the possible outcomes. The probability of getting head in the first toss. Probability of getting head in the first toss is 1/2, right? Out of 2 events, I get 1. The probability of getting head in the second toss also getting a head, the probability is half. Right? These 2 events are independent, therefore the probability of getting head in both events, probability of getting head in both events, that is the first time and the second time, is the first time it is 1/2, and also we need to get the head in the second time. So we get the multiplication of these two. Call it as the multiplication rule. Right? So now you have this example. In this is the activity in your course manual. Please try to do this one. That is, this is the last question on the probability. Right after that, we can talk about some important probability distributions. Right? Important probability distribution. So before that, please read this question and write down the sample space and try to calculate these probabilities. When you right, when doing the question, if you have any questions, you can ask. Right, any questions? First, you need to draw the samples, draw the diagram. We call this as the tree diagram, right? And draw the sample space. So, pair point was 2 times. So, this is the sample space, and these are the possible outcomes, right? So, sample space, you can use capital E or capital S to denote the sample space, and here H and T define head and tail for this possible outcome. Find the probability of getting a head both times. Getting a head both times means this, and probability of getting a head once, tail one. Head one time and tail one time. These two. So probability of getting head in both times mean first time get a head and the second time also get a head. So the probability is 1/2 times 1/2 is 1/4. Getting head once and tail once mean this one and this one, right? If this one happens, if we obtain HT, first time head, second time tail, that means getting one tail, right? Head one and tail one. Again, or එහෙම නැත්නම් HT හම්බුණත් head එක පාරයි tail එක පාරයි ඇවිත් තියෙන්නේ. එහෙම නැත්නම් TH හම්බුණත් head එක පාරයි tail එක පාරයි ඇවිත් තියෙන්නේ. So there are two possibilities. Right? There are two possibilities. The probability of getting head once, probability of getting head once and tail once, right? That means probability of happening these two events, HT or TH. HT or TH. මේ සිදුවීම් දෙකම වුණොත්, මේ දෙකෙන් ඕන එකක් වුණොත්, මේ event එක වෙනවා. Right? So how we find that is probability of H and T plus probability of T, H, right? Probability of HT means first time we get H and second time we get T. The probability is 1/4. Here also 1/4, right? So 2/4 is half. Right? Or you can write here, this is this probability getting head half, getting tail half, right? On the arrow, this in this tree diagram, right? On this branch, top of the branch, we can write down the relevant probabilities, chance of happening this event, right? This one and this one. So get the product here. But here you have the summation. Right? This place we get the product. So think about it, right? Think about why we get the what I am saying here. Happening this event means first time get H and second time get T. Then only this event happens. Right? So how I calculate this here as a multiplication rule. Half multiplied by half. When this happens. Right? And getting one tail and one head at one time means this one or this one. Right? Because of that here use 1/2 plus 1/2. Or we can calculate it considering the possible outcomes, possible number of possible occurrences, right? Possible occurrences here. Again, for this one, getting head once and tail once, it is 2 over or total number of occurrences 4. Again, we get the same result. Outcome satisfy this condition. Possible occurrences divided by the total number of outcomes. right? So we can write it as the number of favorable outcomes over total number of outcomes. Any questions? Right? Practice these things, right? Some of you, these are very new for you. So some of have some knowledge because in O levels also we talked about the probability and sets. කුලක ගැන probability චුට්ටක් කතා කරනවා. වගේ සමහර අයට මේක තේරෙන්නත් පුළුවන් හොඳින්ම සබ්ජෙක්ට් එකේ තියෙන සමහර අයට තේරෙන්නේ නැති වෙන්නත් පුළුවන්. But you should try to get the idea what we can do using statistics. මොනවද මේ සංඛ්‍යානය කියන එකෙන් කරන්නේ? අනේ අදහස තමයි ගන්න ඕන. මොකද මේක ගොඩාක් වැදගත් වෙනවා ඔයගලන්ගේ ඔයගලන් කවදා හරි ඔයගලන්ගේ මේ රිසර්ච් එක කරනකොට data ටික ඇනලයිස් කරන්න කියන තමයි වැදගත් වෙන්නේ. මේ probabilities කියන ඒවා ගැන මේවා ගැන මේ ලොකුවට ගණන් හදන ඒවා distributions ඒවා ගොඩාක් දැනගෙන ඉන්න අවශ්‍ය වෙන්නේ නැහැ. හැබැයි basic idea එකක් තියෙන්න ඕන. මොකද hypothesis testing කියන්නේ lecture number 6 hypothesis testing is a very important part in your research study. Right? ඒ theories හැදිලා තියෙන්නේ all the theories are based on the probability and the descriptive data analysis, right? So you should know very important basic points under statistics. Right? ඒක නිසා මේකේ මේ ගොඩාක් ගණන් හදලා හැම ඔයගොල්ලෝ time waste කරන්න යන්න එපා. ඔයගොල්ලන්ගේ manual එකේ තියෙන problems ටික කරන්න වන්දන tutorials කරන්න හරි idea එකක් තියාගත්තා නම් ඇති. හරි formulas පාඩම් කරන්න ඒවා අවශ්‍ය නැහැ කොහොමදවත්. If you need some formula for the calculation, I will provide it with the exam paper. Right? But if I ask you to write down the sample space for this experiment, when you toss a pair coin 3 times, write the sample space, you should be able to write. Very simple questions, right? If you get the idea, you can write it. Any questions? Right, I will upload your quiz. Put the quiz to the LMS. It's a LMS quiz, right? All the questions are MCQ questions. So to do this, right? To start the question, start your quiz. Before start your quiz, please go through all the notes. Right? Sometimes rather than answering the essay type question, sometimes it is very difficult to answer for the multiple choice question. So, right? So MCQ questions. Right? Because you have one question, there are several answers. Out of these answers, you need to select under MCQ. LMS quiz, you will get several MCQ questions as the quiz, LMS quiz. Right, so that's all for probability. And let's go to the probability distributions, right? Under probability distributions, I'm going to talk about some discrete, we know discrete random variables and continuous random variables, right? I said you for discrete random variables, we can talk about discrete probability distributions, and continuous random variables, we can talk about the probabilities for range of values, right? So we can talk about continuous probability distributions, right? Only 3 distributions we can discuss, right? Mainly the binomial distribution and the Poisson distribution and and the normal distribution, right? This is very, very important distribution. So, what we are going to do here, right? Like we know that for the random variables, right? Random variable means it represents some characteristics and it can take different values, right? So now we are going to see according to some characteristics of the random variable, in some situations we can define some probability distributions for that random variable, right? We give different names. We give that random variable follows a binomial distribution. That random variable name, for an example, I can say the random variable x random variable. I have a random variable like y. Y is the marks of the student or weights of the student, marks of student, right? I can say y follows a normal distribution. My y has data. What are these data? Student marks. You can say that student marks follows a normal distribution. Right? Like this way, we are going to talk about some important distribution that the random variable can follow, and what are the properties, characteristics of that random variable to follow that distribution. Right? We know that a random variable is a function that assigns a numeric value to different events in the sample space. Right? Random variable means a function. It can assign. Now, random variable can take different values, right? Suppose a random variable, I assign the values 0 and 1. We can say it's a function. It has some according to some relationship. It assigns this type of numerical values to different events in your sample space. Right? Related to some experiment, you have the sample space. In the sample space, you have several events like 1, 2, 3, 4, head and tail event. For these events, we assign some numerical values by using this random variable, through this random variable. Right? A random variable can be a discrete one or continuous one. For an example, outcomes of a lottery drawing. Outcomes of tossing a pair coin. Right? We can get head or tail. Right? We can assign two numerical values for those outcomes. Right? Possible values as 0 and 1. So the random variable can take these values 0, 1. 0 and 1. So specific value that one assigned to the outcomes of experiment denoted by simple x1 up to x3, x1, x2 up to x3 and so forth. The function x transform these outcomes to the experiment into real numbers. Function, we say x is a function that transforms these outcomes to the real numbers. In the real numbers, outcomes of the experiment transfer to the real numbers, we called as a random variable. So discrete random variable and continuous random variable, we know x is discrete means it can take discrete number of values. And finite or some countable number of values, right? It is discrete random variable results from counting something, right? Number of rooms in a house. So discrete random variable, we count. Number of defective items in a production batch. Right? And random variable, continuous random variable, it assumes uncountable infinite number of values within a certain limits, right? if we consider the weight of a student in grade 5, right, I can say that it can vary from 15 kilogram to 20 kilogram. It can take infinite number of uncountable values. I don't know which value will be the weight. If I measure the weight of the student in grade 5, it can be any value in between two defined values. Length of iron bar, depending on the accuracy, how we get the measurement, we can see some discrete values, but can take infinite number of values. So it's a continuous random variable. Right. So along with these continuous random variable and discrete random variable, we can talk about discrete and continuous probability distribution. Right? Under discrete probability distribution, the first distribution is the uniform distribution. Uniform distribution. What is the uniform distribution? A uniform distribution is one for which the probability of occurrence is the same for all the values of x. For all the values that x can take, the probability of occurrences are same. For an example, if a fair die, if we roll a fair die, right? You can get 1, 2, 3, 4, like up to 6. Obtaining any one of the 6 possible outcomes, obtaining any one of these outcomes is 1 over 6. So we can say that it follows this random variable follows a uniform distribution. Because these outcomes are equally likely to happen if it was if we roll a fair coin, a fair die. Right? So if the random variable x, assume x can take these values up to simple x1 up to xk with equal probabilities, then the discrete uniform distribution. So we can write the distribution form using some formula, right? Like probability of random variable value is equal to simple xi. Like this value is always same probability, like 1 over k. Right? If there are k number of outcomes. Right? So here this example shows you, suppose that a plant is selected at random from a plot of 10 plants to record the height. Right? Please read this example first. Read this. Right? It says what? Suppose we have, we select a plant at random from a plot of 10 plants. Right? We have the 10 plants and we record the height. Then we have 10 plants and I select one and record the height. Then again select another one, record the height. I don't know which plant will come, but each plant has the same chance. 1 over 10. Out of 10 plants, I'll select one. Each plant has same probability of being selected. Right? If we assume that these plants are numbered the same way, right? So we can say that the distribution of selecting plants are uniformly distributed. Then this is a little bit different, right? Binomial distribution. This is like I have a random variable and it can take different values, right? Not like in uniform case. Here there are several characteristics that distribution should follow. Right? In the previous case, uniform distribution for all the outcomes, all the happening chance of getting all these outcomes has the same probability, right? But here you have another one, right? We conduct some experiment, and according to the characteristic of it, we define that the random variable follows a binomial distribution. Right? Please go through these 4 points. Read those 4 points. Write what this says. Binomial distribution is one of the simplest and most frequently used discrete probability distribution. This is a discrete probability distribution. It is very useful in many practical situations involving two events. Right here, the experiment has only two events. It can be a success or a failure. Right? The first one, the experiment performed under the same condition. We conduct some experiment several times under the same condition. Fixed and finite number of trials, right? I conduct the experiment, simple n number of trials, 1, 2, 3, up to suppose I conduct this experiment n number of trials. අපි n වාර ගානක් එකම එක්ස්පෙරිමන්ට් එකක් n වාර ගානක් කරනවා එකම conditions යටතේ. Right? Coin එක fair coin, I will toss a fair coin 3 times on the same condition. The results of each trial can be classified into one of the two categories. Next characteristic is, right, result of each trial. Each trial result we can divide it into only two categories, right? Success or failure. In the second time also, we can get a success or failure. In the nth time also, we get a success or failure. The probability of success remains constant from trial to trial. So we say the probability of getting a success is always equal, P, the same value for each trial. Then the probability of failure is, the probability is 1 minus P, because the probability, total probability should be 1. Right? Each trial is independent for other trial. There are no dependency between these trials. Right? If these conditions satisfied, right? If these conditions satisfied, so then we say, right? If we define capital X random variable, right? Sequence of n independent trials, if we are interested the probability of the successes from n trial, capital X I define as the number of successes I want to define what is meant by success. සාර්ථකයක් කියන්නේ මොකක්ද කියලා define කරන්න ඕන, right? So, if we toss a coin, I can define the success as a head or tail, right? Or yes or no. Like this way, I can define what is success. Right? Number of successes from n trials, from n number of trials. I conduct the experiment n number of trials, and the number of successes, if I define as capital X, then we get the binomial distribution where X takes the values from 1, 0, 1 up to n. Then what are the values this capital X can take? Simple X can take values simple X 0, 1, 2, 3 up to n. Right? The random variable X is said to be follow binomial distribution with these parameters N and P if its probability function is given by, that is the probability of number of successes equal to simple X. If we can write it as this way, right, we can say that the random variable X follows a binomial distribution. If X follows a binomial distribution, right, then we can find this probability of random variable X equals simple X using this formula, that is Nx. Nx means NCX times success probability, the power X times mean multiplication, right? Multiplication 1 minus P. Here Q means the 1 minus P. Q times n minus x. This is the formula where simple x can take values from 0, 1, 2 up to n. P is the probability, success probability. Right? So, here, since it's a distribution, we can talk about the mean and variance of the distribution also, right? We are not going to talk about more details, right? These are the properties of the binomial distribution, right? You can please go through these and try to understand the same thing we discussed here. And also another important thing is, if n is large, that means the number of trials that the experiment can perform is large, right? If either P or Q is too close to 0, the binomial distribution can be closely approximately equal to the normal distribution. It's standardized normal, right? So it's this is according to the theories can happen, right? No need to remember these formulas. Now let's see why this binomial distribution is important. Sometimes you have to calculate some probabilities related to the things in your study area. Right? For example, binomial probability distribution is a discrete probability distribution. So it is useful in describing an enormous variety of real-life events. For an example, suppose an experimenter wants to know the probability of obtaining disease trees in a random sample of 10 trees. Right? I have a random sample of 1, 2, 3, 4. I have a 10 number of trees. I select those 10 number of trees randomly. Suppose I select those from a forest. If 10% of these trees are diseased, right? The answer can be obtained from binomial distribution. That is, if we consider one tree can be a diseased one or good one. Only 2 outcomes can happen, right? So that the tree is a good one or defect one, the probability remains same in each trial. Right? So in that type of a situation, the binomial distribution we can use to know the distribution of number of seeds germinated out of the lot of seeds gone. Right? So these are some practical examples. We need to think about how we apply the theories, right? In related to your field, yeah, we have to use the binomial distribution. This is an example. So, but you should know to calculate some binomial probability also, right? To calculate the probabilities, we can substitute the values for this formula, right? For this formula, if we know n, x, p, q values, we can get the answer for the probability, right? Other than that, we have in statistics, under each statistical textbooks, at the last pages, right? At the appendix, we can see there are several statistical tables like binomial table, Poisson table, normal table, like t-distribution table. There are several statistical tables. On those tables, they have the probabilities created for different x values, different n numbers. They have created the probabilities, right? Calculated probabilities are there. Then just we want to look at the table and give the parameters and find the probability value, right? So very easily we can get the solutions. But today, using the software also, very easily we can calculate the value. Right. So example 1.4, it's a very common and very simple practical example. Please read this example and see how you answer this question. The probability of obtaining 2 boys out of 5 children, right? Now the 5 children, 1, 2, 3, 4, 5, out of 5, getting 2 boys. The probability we need to find. If the probability of a boy is 0.50, right? We consider this first one, he can be a boy or girl. The probability is 0.5. Then girl, the probability is 0.5. The second one also can be a boy or girl with the same probability, boy or girl. The fifth one also can be a boy or girl. Only 2 outcomes, right? The success probability, if we say the success is getting a boy, right? Finding a boy, then this probability is same for all the trials. Or the five items, it is same, right? If the probability of boy is 0.5 at each birth and sexes of successive children are considered independent random variables, right? So independent random variables, the probability of being a boy, right? What is the probability of being a boy? Is the probability of being a boy is 0.5. The probability of obtaining 2 boys out of 5 children, right? The probability of obtaining 2 boys, the number of boys, if we define the x random variable as the number of boys can be 1, 2, 3, 1, 2, 3, 4, and 5. Right? I want to find the probability of obtaining 2 boys out of 5 children. Out of 5 children, getting 2 boys. I want to find this probability. Right? So now, according to the given information, and characteristic of this random variable, here we can identify that this random variable follows a binomial distribution. Test 5 trials. Each trial, we have the success or failure, and the success probability is same. Right? So probability of x equal to, then I want to, since x follows a binomial distribution, so then probability of x equal to, right, how I can write according to the binomial distribution, I can write this probability of, right, we know the probability of random variable x equals simple x is NCX p to the power x, q to the power n minus x, right? So you can substitute instead of simple x here 2, n is 5, c 2, the success probability is 0.5, 2 and 0.53, right? We have to simplify this one. So this is some mathematical one, 5c2 and these two, right? So no need to if we know this value also, we can calculate this one and we can find the answer manual calculation like 3.25, or you can use the calculator and get the answer. But we have the binomial tables. By looking at the table, we can find n is 5 and x is 2, right? N is 5. And here in this table, this is the binomial table. And this first column shows the n value. The second column shows the k value, means here k mean like simple x. Now my simple x is 2. So 5 under n is 5, the 2 is here, right? And what are these values? The first row, these values are the success probabilities, right? These values are the probabilities. Then under it, the middle values. The values in the table in the middle, we have these these are probabilities. So which probability I want to find now? This is 5C2, 0.52, right? 0.5, 5 minus 2, 3. Then now N5, X2, now the success probability is 0.5. Where is 0.5? 0.5 is here, right? So what is the value? 3125. This is the probability. If I solve this one, I get the answer as 0.3125. Right? The same answer I can get by looking at this table, binomial probability table. Right? This is how we use the table distribution tables to calculate the probabilities. No need to solve this, right? Directly you can go to the binomial table and get the value. Right? Any questions? And as the same way for the Poisson distribution also, we have another table, but Poisson distribution, your random variable follows another type of characteristics, right? So this is also very practical. Practically, we can find Poisson random variables in many practical situations, right? First read these points and see what is a Poisson random variable. Right? What is a Poisson random variable? It deals with the problem of counting the number of occurrences of a particular event. We count the number of occurrences of a particular event during a specified time interval or some region of space. And for an example, the emergency cases arriving per hour at a certain hospital, right? The number of emergency cases arrived per hour. Number of emergency cases arrived per hour, right? For a specific time interval. Number of robberies reported in month. Number of telephone calls received for 2 hours or for 5 hours. Right? For a specific time period, number of occurrences. Right? This distribution, so for that type of random variable, we can say it follows a Poisson distribution, and for this distribution is usually associated with very rare cases. Right? Number of successes that occur in any interval, here these are the characteristic number of successes, that is if we say the number of telephone calls, right, getting a call, the number of success is any trial is independent of the number that occur in the other number of successes in the other interval. Right? There are no overlappings on the interval, and the probability of success in interval is proportional to the size of the interval. These are the properties of the Poisson distribution, and this is the formula, right? This is the formula, that is F random variable X. We say it follows a Poisson distribution, right? Random variable X is said to be follows a Poisson distribution with some parameter value lambda. Lambda is a parameter value. What is lambda? Lambda we called as the mean of the distribution, right? Lambda we called as the mean of the Poisson distribution. If we know the value for lambda and simple x value, we can calculate the probability of the random variable is equals to x as e to the power minus lambda times lambda over x to factorial x, right? Where this e value, I don't know what is the e value. In mathematics, e is 2.71. We can directly use this. Now we know what is e. Lambda is given in the question. X is given in the question, right? So how we calculate this factorial x? This is also in mathematics. According to this factorial x, we can write it as this notation also, factorial x. This is simply the product of the values up to this number, this x. Right? If we say factorial 3 means 1 multiplied by 2 multiplied by 3, that is 2 by 3, 6. Factorial 3 means 6. Right? So this formula we can use to calculate the Poisson probabilities. Right? These are some properties of the Poisson distribution, and we can use, right, to calculate the Poisson probabilities, we can use this table, the Poisson probability distribution table. Here you can see we have several tables for several lambda values, right? And the first column shows the R. R is like simple x, right? X vary from 0, 1, 2 up to like some numbers. So lambda can take different values, and this middle value shows the relevant probabilities. Relevant probability. I will show you one example, right? But don't worry about the calculations and calculating the probabilities under Poisson like binomial distributions. But you should know the normal distribution, right? Please, we can come to this one after discussing this example. right? You should know how to calculate the probabilities using normal distribution only. If the random variable x follows a Poisson distribution with mean 3.4, mean 3.4 means here lambda 3.4, right? How I write the distribution? It says x has a Poisson. How we write it? Using this notation. X follows a Poisson distribution with lambda, and lambda is 3.4. It's lambda. And find the probability that the random variable value is equals to 6, right? It is what? E to the power minus lambda 3.4 times lambda 3.4 power x over factorial x, right? This is what? This is simple x, and e to the power minus 3.4 times 3.4 x is 6 and factorial x means factorial x, right? This is a big mathematical calculation here. So, but no need to solve this one. Directly you can use the Poisson table. Poisson table, right? Here, I know the value is x value, simple x is 6. That is here R, right? R is 6 and lambda is 3.4. So where lambda is 3.4? This line, lambda up to 1, right? Here, lambda up to 2 and lambda is 3.4 here. And x, here R, x is 6, right? So select this column and row, and this value gives the relevant probability. The probability answer for that probability is 0.0716, right? If I solve this one, I get 0.0716. So directly look at the table and you can get the answer. Otherwise, you need to substitute the values like E is 2.7. What is it? Is 2.718. 718 power 3.4 and 3.46 over factorial 6 mean 1 times, 2 times, 3 times, 4 times, 5 times 6, the multiplication of all these 6 items. So using a calculator, we can get the answer, right? But using the table, probability distribution table, Poisson table, directly we can get this. Right, now let's go to the normal distribution, right? This negative binomial and hypergeometric distribution, if you have free time, please go through these theories and see when we can apply, but this is important, right? Under the continuous probability distributions, we can talk about the normal probability distribution. Normal distribution. It's like it has this type of a shape, like a symmetric bell shape. Symmetric bell shape. Okay? So the formula for the normal distribution, like in binomial distribution, we have some formula to calculate the probability. In the Poisson distribution also, we have some formula to calculate the probability. The normal distribution also, we have some formula to calculate the probability. It is, we call it as the probability density function, not the distribution. Probability distribution function is here density. Why we say density function? Because here my random variable is a continuous random variable, not a discrete. Continuous random variable, right? So we say we can talk about the probabilities for some range of values. Range of values, what is the probability? Like the area under this range. It gives from this type of a formula, right? For the normal distribution, this is the formula. How we read this? F x random variables was a normal distribution, and the probability x equals simple x is equals to 1 over sigma times square root 2 5 multiplied by e to the power 1 over half right? X minus mu over sigma square. Where x, this random x value can vary from minus infinity to plus infinity. Sigma is a positive value. What is mu is the mean of the distribution, and sigma square is the variance of the distribution. These are standard notations, right? For a normal distribution, mu we use to denote the mean, and the variance we denote from sigma square. This is the formula we use. Here also we have the normal tables, calculate the probabilities. Right? So, but in calculations, we use not the normal distribution, we convert this into a standard normal distribution. Right? It means that in the normal distribution means it's a symmetric distribution. Right? Here my random variable x has a normal distribution. X, right? It has x follows a normal distribution with mean mu and variance sigma square. Right? This is how I write the distribution. So this is the function. This is a if I want to calculate the probability, this is the function. Okay? So how I draw this? For the random variable x, mean is mu and the variability is sigma. Okay, but the normal distribution with mean 0 and variance we call the standard normal distribution. And in the normal distribution, if the mean comes to 0, and the variance is 1, we say this is not x, this is z. Random variable z, we call this as a standard normal distribution. Standard normal distribution. Right? This is z, we say z follows normal distribution with mean 0 and variance 1. Right? This is we call as the standard normal. Standard normal distribution. This is normal distribution. Normal distribution. This is standard normal distribution. Right? Here you can see in the standard normal distribution, no mu is 0. Right? Variance is 1. Right? This is the related to the standard normal when mu 0 and variance 1. Now this x comes to a standard normal random variable. So these are some properties. Area, if we talk about the area covering the normal curve, right? This is the middle point, 0, mu is equal to 0, and we say between 1 sigma, here to this side sigma, and here the minus 1, right? In this interval, power 68% to 7 data from the whole area. And between minus 2 to plus 2, you have 95.5% of data. In between these 3 points, minus 3 to plus 3, the whole area, nearly the whole area covered. And these are the probability normal tables. Actually, these are not the normal tables. We have the statistical tables for the standard normal distribution. Right? For the standard normal distribution, that is Z. For the Z random variable, we have the tabulated probabilities. Right? So we can read the table and calculate these probabilities directly, right, without using the formula. So let's see how we calculate the probability. Using standard normal distribution, find these probabilities. Probability the set random variable less than value less than 1.67, right? So what I want to calculate, probability, now I want to calculate the probability is set random variable value less than 1.67. 1.67, right? Is set. Now I know what is Z. Z is the standard normal, like this diagram. Z is the mean. If this is a random variable, mean is 0, right? So here we have the positive values for the right tail and the negative values for the left tail, right? So 1.67, now I mark the value here. Now 1.67 is the value like here, 1.67, right? Now, what is the area I want? Is it less than 1.67? The Z value less than 1.67. If we consider this side, is it greater than 1.67? So what is the area? The values is it less than 1.67 is these values. These are the values, right? So the probability I want to calculate gives this area. This area I want to calculate. This area gives this probability. Probability is set less than 1.67. So how I calculate it? You want to go through this table, right? Or this one, right? How we define it in this table. This table also in this your course manual, but this is not clear, right? Here we can see the Z values, all the Z values in the first column, these are negative side, right? This side, this is 0. And the Z values like here -1, -2, -3, like this, right? The Z values. And in the next table, we have the Z values for positive. All the positive 0, 0.1, 0.2 up to 3. Positive Z values. And the first row, this first row shows the value of the Z, the second decimal point value of the year Z, right? This column shows the first decimal point. From this column, we can get the second decimal point, right? So the middle value shows the relevant probabilities. Here also, this value shows the probabilities. And the left half of the Z table, right? This probability shows, this probability shows the left half of the Z table. In the Z table, these probabilities shows this half. This half, right? And this half shows the right half of the Z probability. That is this area, right half. Right? Now I want to calculate this probability. I want this. So how we calculate this probability? We can do it in two ways, right? One way is the total area covering this curve is 1, right? From this 1, I can subtract the probability of this part, that is probability of Z greater than 1.67. Z greater than 1.67, right? So what is 1 minus probability Z greater than 1.67? 1.67 Z greater than 1.67 is this area. This, right? So this one I can get from the table 1.67. 1.6 is here. 1.6 and 1.67. 0.7 I can get from this column. All right, 1.67. Then the probability value is this. This is the probability value 0.9525, right? So this is the probability. So this answer gives the answer for probability is set less than, right? If we subtract from 1, if we subtract this area, this probability gives the remaining probability. Right? Is it clear? Let's check the answer. 0.9525 is that 1.67. 9525. So, right half of the set table is something is wrong here. In 95. Oh, right half. Right here, I think this this gives the left half. I think this gives the left half of the set table. So if we consider 1 minus 6, 7, 6, 7 in this, using this one, minus 1.67. So another way is calculating, I think one mistake is there, 1.67. So I want to calculate a 1.67. This 0 is set. So instead of calculating this one, right? This is this probability, I want this one, right? So probability is said less than 1.67. So it should be a probability value like this area, the whole area is 1. So this is 0.5 and so whole area 0.5. So it should be a value, the answer should be 9.9525. The answer should be 9.525. So let's see what is the missing point. Is 1.67 minus 1.67. 1.67 if I get from this side, right? If I get this from this table, these tables are not clear, right? Because if I see this area minus the probability is said less than the left half of the set table, right? This area is the probability is said less than minus 1.67. Right? Is it less than 1 minus 1.67 is 0.0475. Right? So then this half, right? Since this is a symmetric distribution, this is same as this. Right? So what I can write, right? This area also 0.0475. Right? So then what the area I want to calculate, this area, this is I can write it as the Z less than 1.67 as 1 minus 0.0475. Now we get the answer, right? 1 minus 0.0475, right? 5259. This is correct, right? But this table shows the left half, this probability. But this table, I think there is it is not clear. This one, I want to check this again, right? If we take this from this table, 1.67, 9525 means I think this gives the not right. It is not. I want to check this one again, right? So please ignore this one. I will go through your manual and check. We can. I think the manual is in LMS now. We have the manual. What is it? I think it is not clear in the table. In the second table gives the Hall probability. In the public tables, no, it's on your course manual. I think I got it from your department, I think, in the past papers. So what we can do, right? So I think I will give you a new one, right? So this is not clear, right? Since this one is clear, but we need this part also. But this one I got from, I think, a past paper or from the department. I think I received this table, but since this is not clear, I will upload a new one, right? I will upload a new standard normal table. You can work with. So let's try to do these questions from the new table. I will get it. Please give me 1 minute. Right, this one is clear, right? This is the standard normal. Actually, this is clear because this gives some cumulative, the probability here, the cumulative probability. The table in your in this slide also, right? This one also, I think it shows, since it is not clear, it gives the cumulative probability, right, for the left half, and this one also should be the cumulative probability, otherwise this is wrong, right? So please use this table, this one as this one is the same values, 0.3, 6, right, same values, and here, right, and this should be, this table use the cumulative probabilities for positive Z values. Positive Z values, this gives the cumulative, that is from this to that is this one is the probability the Z random variable value less than simple Z, this total probability, right? The whole area gives from these values, right? Cumulative probability for the positive Z values, right? Here, this table gives the cumulative probability values for the negative Z values, like probability Z less than something minus some simple minus Z, right? So according to, if I use this table to calculate this probability, right? Probability Z less than 1.67. That is, if I use, please ignore this table, right? This is, this is not clear. So Z less than 1.67 according to this table, Z less than 1.67 means, right? From this, if I draw, this is 0, 1.67 here, Z less than 1.67 means this whole, for this, all these Z values. For all these Z values, this is the area. This is equal as the cumulative probability Z less than 1.67. So 1.67 is 1.6 here, 0.7 is here. So the probability value directly 9525. Right? So directly we can get the answer. Probability is said less than 1.67 is 0.9525. So this table gives this whole area, right? Cumulative probability for this whole area. So I will upload this one, right? I will upload this standard normal table to the LMS, and please refer this, right? So please go through this using the new table. Try to calculate the probabilities. Probability Z less than minus 1.52. And this one, these two, try to complete these two. I will upload the new table. Right, from the LMS, you can download under lecture notes a standard normal table, right? Please download this table and Get few minutes and try to see whether you can answer part B and C. Draw the standard normal diagram, standard normal distribution, and mark where minus 1.52 and what is this required probability. Mark the probability. That is what I want to find. Probability is Z less than minus 1.52. So this is Z distribution and 0. So minus values on this side. Right? So minus 1.52, I can mark it in this point 1.52. So I want to find Z less than or equal minus 1.52. The Z values less than, right? This is the side less than 1.57. So you need to find this whole area. Right? This whole area gives the probability Z less than or equal minus 1.52. Now go to the table and see what is this area. Right? And here, the next one, I want the probability is greater than 2.01. So this is 0, is it? 2.01, I can mark like in this, right? So 2.01 is a positive value. So the area, what I want, the area is it greater than 2. Is it greater than 2.01 means these values. Okay. So this is the area. And standard normal distribution එකේ මේ හරියට mark කරගන්න point එක mark කරා මේක greater than less than අනුව area එක mark කරන්න ඒක තමයි probability එක හොයන්න. So this probability is set greater than 2.01. Right. Any questions? Now what are the answers? Minus 1.52. So directly to see this probability in the table, right? You can go to the table, standard normal table. The standard normal table, like it's this like this area, negative side, negative Z values, right? For negative Z values, Z value is minus 1.52. So we are 1.52, 1.5 is this 1.5. This is 1.52. 2 you can get from second decimal place. Right, you can read the second decimal place here. Minus 1.52 probability 0.0643. So the answer is 0.0643. The answer. Right, you have the answers also here. Right, now try to find this probability. Please use the standard normal table. Now I upload it to the ULMS. Use this one, right? Use this one. Standard normal table. I will upload another table, so Poisson and binomial. But no need to practice Poisson and binomial tables. But you should know how to read the standard normal table and calculate the probabilities. What is the answer for the part C? This is the answer. You can find this probability in two ways, right? Right, think about it. You can find this probability in two ways. Directly using, you can directly use this table, right? You can use this positive Z values probability table, and you can use this one also. Two ways you can get the answer for this question, part C, right? How we do it? If we use this one, that is the cumulative probabilities for negative Z values. If you use this table, the first table, how you get the answer? How you get the, you want to calculate this probability by looking at the negative probabilities given for the negative side. How you get the answer? Right? Here, this thing is similar. This is similar. This is same as, right? I can write this as this way also. This is same as if I mark this in this tail, right? Minus 2.01 on this side. Is this correct? These two are same, right? Because why these two are same? These two are same. This is correct because this distribution is symmetric around 0. The standard normal distribution or normal distribution, it is symmetric around 0. මේක සමමිතිකයි බිඳුවට. හරි බිඳුවට සමමිතික නිසා මේ පැත්ත මේ curve එකෙන් cover වන the whole area covered under this curve is probability 1, right? The probability, the maximum value can goes to 1. So the whole area covered under this probability curve is 1 because of the symmetricity of the distribution. This half probability is 0.5, this half is 0.5. Right? So if I want to calculate this area, it is equals to calculate this area. Same answer gives. Right? So one way is this. Right? So using the first table, I can see the value minus 2.01. Minus 2.01, 0.0222, 0.0222, right? Or you can find this, by looking at the second table. Second table gives the probabilities for the positive visit values, right? If this is 2.01, if this point is 2.01, this area gives from these values. So now if I read 2.01 here, 2.01, 2.01 is this. 0.9778, right? So this whole area 0.9778. So I want this. This is 1 minus 0.9778, right? Is equals to, this is equals to 222.0222. The same answer you can get from the two tables in two different ways. The answer is 0.220222. Is it clear? හරි ඒක තේරුණාද? right මේ table එක ඔයගොල්ලෝ මම හිතන්නේ මම පාරන question paper එකකින් වෙන්නට ගන්න නැත්තේ department එකකින් එකක් මට නම ඒක පැහැදිලි නෑ right මේක ගන්න එපා මේක ගන්න නැතුව මේ table එක සම්පූර්ණයෙන් අයින් කරන්න අලුතෙන් දාපු table එක පාවිච්චි කරන්න. You can use the new table I uploaded to the LMS, right? The standard normal table. Questions, do you have any questions? Then you can try to complete part D, E, and F, right? Part D and F answers are here. Please try to complete. Right, so now the example 1.7, right? So this is one example how we calculate now. In example 1.6, you have given the set random variable and you need to calculate some relevant required probabilities. Now example 1.7, it gives some story and related to the random variable. And I think it's given that the random variable follows a normal distribution with this mean and the variance, and you want to calculate some probability. Right? So please go through this example 1.7 and see how you write using this according to the question, how you write the probability required to calculate. After that, we can calculate the probability. First, after reading the question, you need to identify what you need to calculate. What you need to calculate here, right? So please go through this and try to write down what is the probability you want to calculate, right? And another point I want to say, if we write X follows a normal distribution with mean mu and variance sigma square, this is the mean and this is the variance of the data. You see the random variable follows a normal distribution with mean mu sigma square. This random variable means, for an example, weight of the student, some data. Weight of the student, mean weight and the variance of the weight, dispersion. Right? We call these as the parameters of the distribution. Right? In the distribution here, the normal distribution has two parameters, mean and variance. Right? Parameters of the distribution. Right? Right. Keep in mind these things, right? So we have very limited time to discuss all these things. So I think it's very difficult for you to understand because it is a new subject, but we have to do this, right? Because I think you will get a simple questions for the exam. So don't worry about more calculations, but do the tutorials. I will upload. You can do the tutorials and get the practice. I will upload this to the LMS. Right, write down what is the probability we need to calculate here. Right, what you think, how you write the required probability? Right, it says suppose male hypertensive is defined as a person whose blood pressure is between 90 to 100. Assume that 35 to 40 years all men's blood pressure are normally distributed, right? Assume that you have a group of students in between this age range and their blood pressure values are normally distributed with mean 80 and variance 144. What is the probability that, right? The question asks, what is the probability that what is the probability that a randomly selected person, if we randomly selected person from this group of age, persons of this age group, right? What is the probability that the randomly selected person from this population will be mild hypertensive, right? If that person is a hypertensive one, right? So how we write it? We say how we define this case. If the person blood pressure, according to the person blood pressure, if the person blood pressure value in between 90 and 100, right? How I write this? If this exceeds the blood pressure, random variable, right? It can take different values. If the blood pressure values are in between 90 and 100, right, we can say the person has some hypertensive. It's a hypertensive person, right? So I want to calculate, if I select a person, what is the probability that he will be a mild hypertensive? So I want to calculate this probability because X is the random variable, right? X is the random variable. It shows the blood pressure. If the blood pressure values are in between these two, that means it gives the probability of getting a mild hypertensive person, right? So here I want to calculate this probability. This is the question. The random variable X is the blood pressure. Blood pressure value. I have no measure for the hypertensive. To measure the hypertensive is the blood pressure, and according to this statement, we can write this probability statement. Right? So now I want to calculate this. Now I want to calculate. To calculate this, I want to know what is the distribution of x. So what is the distribution of x here? මෙතන x ගේ distribution එක මොකක්ද? What is the distribution of x? X is the random variable. It's the blood pressure values of some group of persons in this age range. Then it says that blood pressures are normally distributed, right? Blood pressure values are normally distributed. So it says that blood pressure values are normally distributed with mean 80 and variance 144, right? This is mu, this is sigma square, mu and sigma square, right? So x is distributed as this way. Now I want to calculate this, but I don't know, I have no the tables for probability tables for normal distribution, right? We have this probability table only for the standard normal, Z distribution, another probability distribution for Z, right? So then how I calculate, what I need to do, how I calculate this probability? What we do here is I want to convert this x into Z, right? I want to convert this x into Z, that is, I want to convert x into Z. How I convert x into Z? Standard normal distribution, right? So, how we convert the normal distribution to the standard normal distribution, right? So this is, I show this example for your knowledge, because I'm not expecting this type of question from you, right? So I want to convert this x into Z, right? And find these two values. So how I convert it? X has a normal distribution with mean, mu, and variance sigma square. What we do, you see, that is we subtract from x, I subtract mu, mean. And when we divide it from the standard deviation, this becomes the standard normal random variable. We say this follows a normal distribution with mean 0 and 1, right? It becomes a standard normal distribution. True. So how I convert this x to x, I want to convert x into Z, right? From this we subtract mu and divide it from sigma, right? So the probability statement, from x we subtract mu and divide from sigma, means we have to do the same thing for the both sides. 90 subtract mu 80, divide from 12, right? Here 100 minus 80, divide from 12. Now we can simplify this probability. The value you can find here, I suppose it is A. Now this is Z, and you can find the value 100 minus 8 over 12, right? So I have now I have to calculate the probability that I calculated in the previous questions, right? I have to find the probability that standard normal random variable in between A and B. So using this table, standard normal table, you can calculate the probabilities, right? So in your stage, right, you are not expecting like those do like these type of calculations, but if I can ask some MCQ questions, I can ask what are the properties of the standard normal distribution, right? So you should know these things. If we say the standard normal distribution, that means its mean is 0 and variance is 1. Right? If you look this, if I give you this type of a diagram, you should be able to identify this is a standard normal distribution. Like this type of very basic things you should know, right? So please go through what we discussed, and you should be able to calculate uh, the simple probabilities, right? The probabilities in example 1.7, you should be able to calculate. Okay, any questions? Right. Now, under the probability distributions, right, these are the things I want to discuss. And next, we need to talk about the hypothesis testing. Right. So I think hypothesis testing, since we have only tomorrow, right? Tomorrow we have the lecture, but it is good we can cover some parts today, right? Because this is also very important for you. The theories are very important, but we cannot complete this one today. But I think I want to talk with you about, I want to give you some brief introduction regarding what we are going to do under statistical hypothesis testing, right? After that, tomorrow we can discuss about several calculations, right? Few calculations. So shall we get 10 minutes break, right? 10 minutes break. The time is 4. I will start the session again for 10, right? So I will start the session again for 10, and I want to discuss very few points on hypothesis testing, and after that we can stop the class, right? So please get a 10 minutes break and join again. Hypothesis, right? We call this as statistical hypothesis testing. Right? So under statistical hypothesis testing, we can talk about several points. That is, what are the steps in hypothesis testing, and how we test the single for a one population mean, how we do the test to do the hypothesis testing regarding the population proportions, like that for the one population case as well as two population case, and for more population case we can discuss, right? So what I am saying here is I said you when we collect the data, normally we collect the data from a sample, right? We collect the data from a sample. I have the sample data. So I get this sample, as I discussed in the first day, I get this sample from a certain whole set, whole group, right? There is a whole set, we call it as the population. This is the population. We select using some method, some sampling method. Suppose I have I have suppose this is my population is like let's say population is the employees, right? Suppose my population is the employees in factory A, right? I'm going to do some research regarding the employees in factory A, right? So this is factory A, and this dot shows the employees, individual employees in the factory. Suppose there are 2,000 number of employees, total number of employees in the factory, right? When we talked about the research study, I have some objective. Right? Suppose my objective is to find the mean monthly expenditure of an employee, right? මට ඕන කරනවා ෆැක්ටරි එකේ ඉන්න ඔක්කොම එම්ප්ලොයිස්ලා තමයි මගේ population එක. ඕන එම්ප්ලොයි කෙනෙක් ගත්තොත් එයා මාසෙකට on average කොච්චර එයාගේ expenditure එකක් තියෙනවද? Right? This example, all of you can understand this example. This is a very simple and very practical example, right? These are practically, we want to identify this type of things. What is the mean monthly expenditure of an employee in this factory? Okay. So for that, since I cannot collect the monthly expenditure values from each and every employee, that means it is not practical to collect the data from the population. What we do, we select a representative sample. Suppose I decide to select 300 number of employees from this factory, right? Now they are in my sample, and using the sample, I collect the data. Now I have only one population, I select one sample, right? So here, my interest is I have the sample data, and using the sample data, now I know you have to analyze the data. You can calculate some descriptive statistics. Sometimes you can apply the probabilities, right? So you can do all the things for the collected data based on your sample. If I say in a simple, using simple example, I can calculate what is the sample mean. The notation is X bar, right? Suppose I get the value like the average monthly expenditure for an employee in this factory is 30,000. This is the sample mean. But as the researcher, I want to find the mean monthly income, average monthly expenditure of a factory employee for the population. That is, in notation, I use the notation for the mean population mean mu, right? I want to talk about the mu. right? Suppose the researcher, I don't know what is the actual value for mu, but I can guess. I can think about according to some past information or based on the sample mean value. I can guess that the population mean also a value around this sample mean. Right? So sometimes as a researcher, I have some hypothetical statement that the mean monthly expenditure of an employee can be 32,000 rupees per month. Right? I don't know this is correct or wrong, but this is some hypothetical statement only. I have some hypothetical statement that is the mean monthly expenditure of an employee in the factory A is 32,000. Right? Then how I say, how I test whether this is correct or not? How I do it? We have to use the statistical hypothesis. At least we say we have to develop a hypothesis. We have some hypothetical statement regarding one population or more than one population. We write the hypothesis regarding the population parameters. Right? We write this hypothesis regarding what? Regarding the population parameters. Population parameters. These talks about the population. These are some characteristics regarding the population. For an example, population mean. Population mean is a population parameter. The notation is mu. Right? Another example is population variance, sigma square. It's also a population parameter, population variance. Population variance. So sigma square. These are parameters. I don't know the actual values for these. So I can develop some statistical hypothesis regarding the population parameters and test those. How I test those? Using the sample data. Using the sample data. Right? So it can, this hypothesis, we can talk about the one population parameter or more than one population parameters. Right? For an example, suppose related to like some related to the yield under like suppose I have I have this type of a study like I have the right I have two right these two are the tomato right here we are talking about the some tomato plants yield and the tomato plants right. So here I consider two plots with equal size, right, and under same condition. But for this is the plot 1 and plot 2. I have several tomato plants in both plots, right. For this plot 1, I apply fertilizer type A. And for the second plot, I apply another fertilizer. It is fertilizer type B. I apply two fertilizer types to the two plots, plot 1 and plot 2. Right? Suppose that I want to check whether these two fertilizers gives the equal yield. Whether these two fertilizers shows the same effect on the yield, right? Then you need to think how you have to design this experiment. right? Actually, we have the several research institute like Rubber Research Institute, Coconut Research Institute, right? They conduct this type of experiment. They actually conduct this type of experiments, right? Because they apply the treatments and observe certain period and collect the data, and they come to conclusions, right? So here I want to check whether these two fertilizers type gives the same yield. Then what I want to do, uh, other than these two fertilizer types, all the other conditions that affect to the yield of the tomato plants, I want to keep all these conditions as same for the two plots, right? Because I have two plots. For the two plots, except the fertilizer types, all the other conditions that affect to the yield should be same if I want to test if there is any if there is any significant effect or significant difference between the two fertilizers on the yield. Right? That is for an example. Suppose the mean yield under fertilizer type A is, if I write using notation, mean yield under fertilizer type A is mu A, right? And mean yield under fertilizer type under mu B, these two mean should be changed due to the fertilizer type only. Right? The soil condition and the number of tomato plants and all other conditions, temperature, rainfall, right? All other conditions we should try to keep in the same way as the same for the both plots. We change the fertilizer type only, right? Otherwise, you cannot come to good conclusion. But in actual situation, we cannot control all these things. But when we are planning the experiment, right, we try to control all other conditions that affect to the yield of the tomato plants, except fertilizer A and B. We try to control all other conditions. We try to control when planning the experiment, right? To get more accurate data, we try to control. But there may be some errors. There may be some uncontrolling factors. Some factors we cannot uncontrol. Right? So in this case, I have like two population means, mu A and mu B. Right? So suppose here, I want to test this type of a hypothesis. I have a hypothetical statement like this. The fertilizer type A gives higher mean yield than tomato yield than fertilizer type B. So using the standard notation, I can write this way. That is, the mean yield under fertilizer type is greater than mean yield under fertilizer type B. So this is a statement, hypothetical statement regarding the two population means. Two population means. Right? So we develop this as a hypothesis and we are going to test this using the sample data. So as the sample data means what we do, we select a sample from this one and we select a sample from this one. Actually, these two are samples. We have the related relevant populations. Right? The experiment we conduct is the sample, our sample. In actual situation, we have the population of tomato plants under fertilizer A, population of tomato plants under fertilizer B. Right? So we can, when we do the experiment, we can get these two as our sample, but we can imagine those two samples comes from a certain their population, relevant populations, right? So always we have the hypothesis regarding the population parameters. You cannot write the hypothesis using the sample statistics, right? Sample value, sample mean, sample variance, you cannot write, it's wrong. Right. So statistical hypothesis is like this. We have some hypothesis and we are going to test it using the sample data, right? So statistical hypothesis test is a method of statistical inference. This is actually advanced part in statistics. Under statistical inference, we use this one to decide whether the data at hand sufficiently support a particular hypothesis. We have the data at hand. We have some sample data, right? Using that sample data, we are going to decide that a particular hypothesis support these data supports for the hypothesis or not. Right? For an example here, in this example at the bottom of this slide, you can see, right, how we write this hypothesis statement, right? In a hypothesis, you have two parts like H naught and H1, right? In H naught side and H1 side, you have two statements, right? For an example, here the parameter is the population mean mu. So two contradictory statements. Mu is the mean birth weight. Mean birth weight, right? H naught says mean birth weight is equal to 2,500. H1 says it's not. Mean birth weight is not equal to 2,500. Right? In these examples, right, researchers want to investigate whether there is a significant association between the amount of physical activity and weight loss. Right? We don't know whether there is a relationship or association between the amount of physical activity and weight loss if we consider certain population, but some researchers want to study. So here also we can develop a hypothesis. Right? A public health agency wants to determine if a newly developed flu vaccine is effective in preventing influenza in a population. Right? So we can have some hypothetical statement. Right? A marketing analyst may hypothesize that the mean family income of a certain area is some specific value. He has some hypothetical statement regarding the population parameter, right? So that statement we can convert into this type of a hypothesis. So in a statistical hypothesis is an assumption either about the form or about the parameters of the population, right? If all the parameters are completely specified, hypothesis is called a simple hypothesis. Otherwise, we call it a composite hypothesis. An example for simple hypothesis is if we say average height of a tree is 50, right? Mean height of a tree is 50. If I say like this, I can say that is mean value is some specific value. Some specified value here for the average or mean. This is we called as a simple. If I write H for the H naught as like this way, mean is 50. This is a simple hypothesis. Right? Mean is 50, and always when you write the hypothesis, there is a another side also here, H1. Right? Mean is not equal to 50. Right? So it's a simple hypothesis. And an average height of a tree is greater than 50, right? If you say H naught side, you have like this, you greater than 50. It says that the average height is, here it says the average height value, this line shows the average height, it says it is 50, right? Here it says it is greater than 50, not a specific value. So we can, it as a composite hypothesis. Right? So this H naught and H1 has two names. In a hypothetical hypothesis, we have these two. These two has two names, like H naught side we call the null hypothesis, and the H1 we called as the alternative of it, alternative hypothesis. Some books we use H subscript A, capital A, alternative hypothesis. So H simply. හරි. එතකොට හැම වෙලාවෙම hypothesis එකක් කියන්නේ යම්කිසි කල්පිතයක් අපි දන්නේ නැහැ ඒක හරිද නැද්ද කියන එක දන්නේ නැහැ. හැබැයි population parameter එකක් ගැන. එක population parameter එකක් හරි කීපයක් හරි වෙන්න පුළුවන්. අපි ඒක hypothetical statement එකක්. ඒක true the false කියලා බලන්න යන්නේ sample data පාවිච්චි. Right? So in null hypothesis, what is the null hypothesis? The hypothesis under test of a sample study is called a null hypothesis. The hypothesis under test for a sample study is null hypothesis. It represents a theory that has been put forward either because it is believed to be true or it is to be used as a basis for argument but has not been proved. Right? This is believed to be true, but it has not been proved yet.
Recording in
The two
progress.
drugs, drug 1 and drug 2 means are same like that. Right? So the alternative side of H1, H naught is we called as the alternative hypothesis. The null hypothesis and the alternative hypothesis, right, we write as this way, H naught versus H1. There are two statements, right? The statements are usually expressed using the population parameters. This one I can write as a statement also, right? It's the population mean is equal to 2,500. The population mean not equal to 2,500. Using the notation mu, I can write this way. The null hypothesis denoted by H naught is the hypothesis that is to be tested. This is what I want to test, right? We always assume null hypothesis is true. We always assume this is true until we have sufficient statistical evidence to conclude this one. We are going to find the evidence using our sample data, right? Using our sample data, we are going to find some evidence whether we can accept, we can reject this one or we do not reject H naught. And whether we can say this is true or false. The null hypothesis denoted by H1 is the hypothesis that some sense contradicts the alternative hypothesis denoted by H1 is the hypothesis some sense it's contradictory of the null hypothesis. Always it's a contradictory, right? So we can write the hypothesis in three different ways, like this way, right? Mu, I can write this one as mu equal H naught mu equal 2,500. Then H1 I can write mu not equal to 2500. Right? Or if I write H naught as mu greater than 2500, right? That is in H naught side. This is the values that mu can take, is the 2500. H naught side I have mu greater than 2500. H1 side means the contradictory, that is mu less than, right, greater than or equal, mu less than 2500. In H naught side, right, or I can write this as mu less than or equal to 2500. Mu less than or equal mean this side, right, 2500. Then for the alternative side comes mu greater than 2500. Right? Like this way, I can write the hypothesis in 3 different ways. Right? So, according to how we write the hypothesis, we can say it's a one-tailed test or a two-tailed test. Right? An example, mean height of trees in a particular type of species. Right? In some area, some specified value, mean height of trees in the area is mu is equals to some value mu naught. This is my hypothesis, H naught. Right? If then H1 side, we can write this way also mu equal mu naught. In some books they use mu equal mu naught, and H1 side I can write mu equal not equal mu naught, or mu greater than less than mu naught, or mu greater than mu naught. Like this way also we can write, right? Here H test mu equal mu naught. Right? Or other way, we can write the hypothesis as this way also. And so, in that case, right, when we look at this hypothesis, right, in the ways we can write the hypothesis, we can say this hypothesis is a one-tailed hypothesis or two-tailed hypothesis. Right? One-tailed test means, one-tailed hypothesis means it's a test in which the values of the parameter being studied under the alternative hypothesis are allowed to be either greater than or less than the values of the parameter under the null hypothesis, but not both. Right? If in the alternative side, right, the parameter value can get only greater than or less than value, but not both. In two-tailed test, a type of statistical hypothesis that check if the sample is significantly different from hypothesized population parameter in either direction. Right? That is right here in this hypothesis. Let's go to the stone, right? In this hypothesis, I explain you how we identify one tail or two tail, right? Here, H naught true, H naught is correct when mu equal 2500, right? H naught is correct, mu equal 2500. Then how H naught is false? H naught correct, mu equal this one, H naught false, mu not equal 2500. Mu not equal 2500 means from this side, or it can be in this side. Right? So we say this one is a two-tail hypothesis, two-tail. That is, the H naught can reject in two tails. Two tails it can reject. Right? If we say it is true if it is equal to 2500 only. Right? Here H naught is true when mu greater than or equal 2500. This is, and here H naught is true. But we say it is false, right? It is false mu less than 2500. Mu less than 2500, we reject H naught. We say H naught is false. So here we say H naught is false. In this region, we say H naught is false. Right? Here, H naught false, we can say according to only one region. So this tail is a one-tail test. This hypothesis is a one-tailed test. Here, mu less than 2500, mu less than or equal 2500, we say H naught side says mu less than equal 2500 mu, right? And mu greater than 2500, H naught false, right? So H naught false when mu greater than 2500, only one tail. So this is also a one tail test. So this is how we identify. So these are one tail tests. H1 side. Looking at the H1 directions, we can identify whether my hypothesis is a one tail test or a two tail test. And also we can say it's a one tail, left tail or right tail according to how you write the hypothesis. Right? Any questions? And I will give this one, right? I will discuss this one only and I stop from here. And you need to think about little bit more for this, what I am saying under this by looking at this table, right? You need to think about little bit more and I will give you one example tomorrow. Right. Under hypothesis testing, right? Now, hypothesis testing means I have some hypothetical statement, H naught, right? There is a contradictory statement also, H1. But I don't know H naught is true or false, but till my sample data says it is true, I don't know it is true. Till my sample data says it is true or false, I assume that it is true, right? Assuming H naught is true, we perform some calculations and come to the decision, right? So, when we are doing the hypothesis testing, actually I based on one sample. Practically from the population, I select one sample and collect the data, right? That is the practical situation. So, there can be two types of errors can happen. There can be two types of errors can happen under statistical hypothesis testing. Right? What are these two types of errors? We called as type 1 error and type 2 error. Type 1 error and type 2 error. Right? What are these two types of errors? That is, I have H naught and H1. Right? H naught versus H1. So, in the actual situation, how these two types of errors can happen, right? Think about this. In the actual situation, actually, this H naught, right, can be a true one. Or actually, this H naught can be a false one. Right? ඇත්තම විදිහ ගත්තොත් දැන් මේක H naught කියන එක මම දැනට හිතනවා හරි. මේක තමයි මේක සත්‍යයි කියලා හිතාගෙන කරගෙන යනවා. ඒකට sample evidence වලින් මේක වැරදි කියලා આવොත් decision එකට එනවා. හරි කියලා આવොත් එහෙම decision එක ගන්න. Right? But there may be some two types of errors can happen. In the actual situation, ඇත්තම situation එකේදී මේ H naught හරි වෙන්නත් පුළුවන් වැරදි වෙන්නත් පුළුවන්. Right? But I get the decision, I do some calculations assuming H naught is true, but in the actual situation, it can be true or false. But when we talked about the decision made, right, we get the decision based on the sample data. When we talked about the decision made, according to my decision, sometimes I can say, I reject H naught. That means I say H naught is false. I say I reject H naught, right? Or I say I can accept H naught. I can say H naught is true. So now think about what this middle value shows you, right? So these four conditions can happen. That is, in the actual situation, H naught can be true and H naught can be false. According to my decision, I reject H naught or sometimes I accept H naught. So this one we called as, right? This one we called as a correct decision. This one also we comes to a correct decision. Why is that? In the actual situation, right? Let's see this one. In the actual situation here, actually H naught is true. Actually H naught is true. According to my calculations, let's for example, I say I accept H naught. That means I say H naught is true. So it's a correct decision. I come to a correct decision. Right? Here also I come to a correct decision. Why? Actual situation H naught wrong. Right? The actually H naught's wrong. But according to my sample data and my calculations, I come to the decision that I reject H naught. I reject H naught means I say H naught is false, not correct. So it's also a correct decision. These two are correct decisions in statistical hypothesis testing, but other than these two, there may be another two types of errors can happen. In these two cases, we come to wrong decisions, errors, right? What's this error? Type 1 error. Actually, H naught is true, but I say H naught false. So it's an error, right? And here, actually H naught false, H naught wrong, but I say accept H naught. H naught is true. Actually it is false. So it is also an error, wrong decision. Right? So according to these errors, types of the errors, we define this one as the type 1 error and this is as the type 2 error. Right? Here, this table also summarizes the same thing. Type 1 error is, right? Type 1 error is the reject the true H naught when H naught is actually true, right? We reject H naught when H naught is true. We reject H naught when H naught is true, right? When H naught is true, we reject H naught, that means an error. Right? Here also we get it, that is another error, that is failing to reject H naught, that is we do not reject H naught. Actually it is false. Actually it is false, then we should reject it. Actually it is false. Our research should say that it is false. We need to reject it, but we do not reject. Failing to reject it, right? So it is also an error, right? This is also an error. So please go through these things once again and try to get the idea, right? So this is really important for you, not for this exam, right? Don't think about the exam, right? But these are very helpful to you in your higher studies, right? So try to get what I'm saying here and what we are doing under statistical hypothesis. I will give you one example for this tomorrow, right? And we can talk about these terms, right? These are very important terms. And after that, we can talk about few calculations, like how we how we test do the statistical hypothesis test, right? So, any questions? Any questions? Right, these are a little bit difficult, but you should try to understand. Right, tomorrow, for the tomorrow lesson, I will upload the Zoom link, and please join for the tomorrow lecture also, because we need to complete this one, hypothesis testing, and we need to talk about the correlation analysis, right? How we calculate the correlation values and interpret it. After that, we can discuss some examples, right? Some questions. So please go through what we discussed, and also you should try to calculate these probabilities, right? You should try to calculate these probabilities under example 4.6, and if you have questions, you can ask at the tomorrow lecture also. And please go through what we discussed under statistical hypothesis testing, and we can continue the lesson tomorrow. Right, then if you have no questions, I'll stop the meeting and I will upload the recording. Right, then thank you very much for joining. Right, tomorrow also you have the lectures for the both groups. Right, please join tomorrow. And I will start the lesson from this point. Right, thank you very much for joining. I will stop the meeting now. Okay.
Recording stop.